Hi guys, welcome back with another video. In this video, I'll be discussing about what is LangChain exactly and why we use LangChain for the LLM apps development. We also use LangChain for the LLM apps development because LangChain is having some ecosystem. We also call it as LLM apps tool. So these are the ecosystem we can also use for the LLM apps development. So first of all, let's try to discuss why LangChain. Okay, why we usually use LangChain for the LLM apps development. So I think you know guys, in generative AI. Okay, in generative AI. So here just let me write down LangChain. LangChain. So in generative AI, we use something called large language model. Okay, yes or no? Definitely we use something called large language model. And there are so many provider. If I just write many provider, like I can write OpenAI, then we have something called Llama, we have Mistral, okay, and so on. Okay, so these are nothing but these are actually, so they are providing something called large language model. Okay, LLM. And what is the problem with the LLM? So let me list down here problem. So the first problem, you'll be getting a limited context window. Then it is having outdated knowledge base. Then it is having data privacy. Then definitely cost involvement is also there. Okay, cost involvement is also there. Then no connection with third party tools. Okay, and so on. So whenever we create any kinds of Gen AI applications, Gen AI apps. So what are the functionality we have? So the first functionality, I think you know, we have data input functionality. Okay, data in. So here what we can do guys, we can give any kinds of data as an input. Let's say we can give .txt file, we can give .pdf file, we can give .csv file, we can give .sql file. Okay, then I think XLS is there, then HTML is there, and PNG file also we can give, and so on. Okay, and our application action wise, what happens? We can implement RAG, we can implement agents, we can implement APIs, format, manipulate we can also do. Then we can also perform the transformation. We can add the memory. We can connect with third-party tool and so on. Okay, and as an output, we get anything. Okay, it can be, there's a text output, it can be image output, it can be audio output. Okay, anything you can get. So this is what actually we usually implement whenever we create any kinds of Gen AI applications. Okay, and these are the functionality we should have. So now what happens, let's say whenever we want to create this kinds of application, so definitely we'll be using some provider. Okay, let's say you want to create these kinds of application with the help of OpenAI. Now previously when we didn't have any kinds of, let's say, orchestration framework like LangChain, LAMAIndex, okay, Haystack, how people used to create? So they used to learn the OpenAI. Okay, let's say OpenAI, I think you know that OpenAI is also let's say a framework, okay, in Python. With the help of that, you can load the GPT model, you can create the RAG application, okay, you can connect the vector database, you can do it. Okay, so with the help of OpenAI also, you can create the application, and that will have also these kinds of functionality. Now let's say you don't want to use the OpenAI, now you want to use the Llama model. That time what to do? Can you load the Llama model with the help of OpenAI? No, it's not possible. For this, again, you have to learn the Llama framework. Okay, I think there is a framework called Llama CPP. Okay, so that particular framework you have to learn, then you will be able to load the Llama model. Then again, you have to again learn the like how we can add the, let's say, memory, how we can load different kinds of data. Okay, how we can perform all kinds of actions, you have to learn separately. Now let's say you don't want to use the Llama, you want to use the Mistral model. That time what to do? You have to learn the Mistral framework. That means what is happening? Okay, if you're using any provider, any other provider, let's say Falcon, Gemini, so you have to learn those individual frameworks separately. And as a developer, it's not possible for us to remember all the framework, right? It would be hard task for us. So that's why we don't use these kinds of, okay, individual framework to work with the GenAI application. For this, some, okay, for this some common framework should be there, some common orchestration framework should be there, so that with the help of that we can load all kinds of model, we can perform all kinds of tasks, we can load all kinds of data. Got it? So that is why actually your LangChain comes into picture. Okay, LangChain comes into picture. LangChain. So what is LangChain? LangChain is nothing but it's a orchestration framework. Okay, or orchestration framework. Orchestration framework. What does it mean of orchestration? That means with the help of LangChain, you can perform everything. You can load the data, you can perform all the actions, even you can get all kinds of output. That means you can entirely orchestrate the application. Okay, you can build the application entirely with the help of this particular LangChain, and this is a universal framework. That means it can load all the large language model out there. Got it? Now if I go to the LangChain documentation, so just search here, let's say LangChain. Okay, LangChain documentation. You'll see that they have one amazing documentation. You can refer their documentation and you can learn about the LangChain. Okay, so they have given some amazing, let's say, tutorial. They have given amazing some, let's say, example. With the help of that, you can learn the LangChain. Got it? So in this program, I'm expecting, guys, you are familiar with the LangChain. Okay, because here we are learning the LLMOps, and whatever things you need for the LLMOps from the LangChain itself, I'll try to cover that part. So LangChain is also having one ecosystem. Okay, in the ecosystem you have something called Langsmith, LangGraph, and LangSharp. Okay, so let me write down here. LangChain is having a ecosystem. So it is having something called Langsmith. This is a, I think, Smith. Let me just write it. Langsmith. Okay, this is a LLM ops tool. Okay, then we have something called LangSharp. This is also a LLM ops tool. Then we have another one called LangGraph. Okay, this is a agentic AI tool. That means with the help of that you can create the AI agents. So for our LLM ops, we'll be using Langsmith and LangGraph. So with the help of Langsmith, we can monitor our GenAI application, and the LangSharp we can serve the model. Okay, we can serve the model. Got it? So again, LangChain is I mean, one of the great framework in the field of GenAI. It not only provides the entire orchestrated, let's say, functionality, even you can also use it for the LLMOps development. So you can see the documentation. So it is having different version like V1, V2, V3. Okay, in the updated version of LangChain, there is a concept called LCL, that is LangChain Expression Language. Nowadays, people use LangChain Expression Language. Okay, whenever they develop any kinds of projects. Okay, but still the legacy LangChain it is being used because some of the functionality you have to use with the help of legacy LangChain. Got it? So yes, guys, this is the introduction of the LangChain. Okay, So it's nothing but it's a framework. It's a orchestration framework for the GenAI application development, because it's a universal framework. That means it can support everything. You can connect with different large language model. You can connect with different vector database. You can connect with third-party tools, third-party data sources. Okay, you can load any kinds of data. Okay, whether it's a PDF data, whether it's a JSON data, whether it's a, let's say data is available in the website, whether you want to load the let's say WhatsApp data. Okay, then you want to load the Slack data. Everything is possible with the help of this particular LangChain. Got it? So that's why LangChain is super important, and you have to learn the LangChain. You have to use the LangChain whenever you are working in the field of GenAI. Got it, guys? So yes, guys, this is all about. I think you understood about the LangChain. Thanks for watching. Hi, guys. In our previous video, we have seen what is LangChain exactly. So we saw that LangChain is an orchestration framework. Okay, with the help of that, we can build the entire GenAI application, and it has some ecosystem also for the LLMOps, right? Now, in this video, we'll be discussing about the LAMAIndex. So what is LAMAIndex? See, LAMAIndex is also an orchestration framework. With the help of that, you can also orchestrate the entire GenAI application. LAMAIndex, we call it as alternative of LangChain. Okay, that means whatever things you can perform with the help of LangChain, the same thing you can also perform with the help of LAMAIndex. But LAMAIndex has one major, actually, let's say functionality, which is called RAG functionality. That means if you want to create any RAG based system, okay, you can use the LAMAIndex there, because to implement the RAG, whatever, let's say, things you need, let's say you need vector database retriever, okay, you need document loaders, so everything's are available inside LAMAIndex, okay, as a function. But whenever we are creating the same thing with the help of LangChain, we have to write some more code. Okay, this is the let's say difference. You will be getting. But tool wise, if you ask me which one is having more functionality, I'll tell like LangChain is having more functionality, because they have recently launched their let's say second generation of LangChain, and they have the ecosystem and all, okay, which is missing actually in the LAMAIndex. That means I think we saw that in GenAI, okay, in GenAI, let me just write down GenAI, we use something called LLM, okay, large language model. And large language model device, there are some provider like OpenAI is there. OpenAI is there. Then we have Llama is there. Okay. Then what we have, guys? We have something called Mistral. Then we have something called, let's say, Falcon. Okay, and so on. So these provides actually large language model, and large language model has some limitation. What are the limitation? I think you know that the limited context window. Okay, then it is having some more problem, like here we had written outdated knowledge base, then data privacy, cost, no connection with third-party tools, and so on. Okay, so we saw that these are the problem can be solved with the help of the LangChain, because LangChain is a universal framework and it is having all the functionality. That means if you have limited context window, you can create something called RAG system, and there you can perform the splitting operation of the data, and you can pass the input to the model. Outdated knowledge base wise, you can update with the help of RAG. That means you can connect with the let's say custom data. Even you can also create the AI agents, okay, to update your model with the latest data. Data privacy wise, you can also handle, okay, you can create some function, okay, on top of that. Cost wise, actually LLM reduce the cost, because if you are using OpenAI, let's say framework, so to use the OpenAI framework, definitely you have to spend some cost, right? So which can be reduced in the let's say LangChain, because LangChain can also connect with open source large language model. Okay, so with the help of that, you can reduce the cost. You can also connect with third-party tools. Let's say you want to connect with third-party vector database, let's say ChromaDB, Faiss, Pinecone. You can also connect easily. You can also connect with different data sources. It is also possible. So the same thing, it is applicable here also. Okay, that means here in this particular, let's say LAMAIndex, what you can do, you can handle the limited context window, outdated knowledge base, data privacy, cost, and you can also connect with different data sources. Okay, and GenAI app wise, I think you know that as a data input, we usually load different data file like txt, pdf, csv, excel, okay, then xls, then html, png, and so on. And action wise, we perform different operations like rag, agents, api, okay, format, manipulate, transform, memory, third party tools, integration, and so on. And output wise, we can get anything. Okay, so the same thing we also can consider inside LAMAIndex. And what was the problem we saw that, guys? Let's say if you want to create an application, if you don't have these kinds of orchestration framework, what you have to do, you have to utilize the separate framework. Let's say I want to use the OpenAI, so I have to entirely learn the OpenAI framework. Let's say I want to use the Llama model, I have to learn the Llama framework. I have to load the Mistral model, I have to learn the Mistral framework. So it's a very challenging task, okay, to remember all the framework and to learn all the framework. So that's why we use some universal framework, universal orchestration framework. Okay, so the first orchestration framework we saw the LangChain. The second orchestration framework you can consider, which is nothing but LAMAIndex. Okay, LAMAIndex. So this is the alternative of LangChain. Now if I show you the LAMAIndex documentation, so just search here llamaindex.ai. so this is the website of LAMAIndex. Even they have the documentation, so I think documentation is there somewhere. Even you can also search here, let's say LAMAIndex documentation. So this is the documentation of LAMAIndex. Okay, so here you can learn like how we can use the LAMAIndex, how we can install the LAMAIndex, all the code snippet they have given. Okay, and whatever functionality we need for the LLMOps, we'll try to show you, okay, in this particular program. So yes, guys, this is what our LAMAIndex is, and we saw the importance of these kinds of orchestration framework, because GenAI application building is not an easy task. Okay, for this we have to take care each and everything. Okay, and everything can be handled with the help of this particular orchestration framework. So yes, guys, I hope you understood and you like this video. Okay, thanks for watching. Hi guys, welcome back. In this video, we'll be discussing about what is a Haystack. Okay, so let me just write down Haystack. So maybe you have already heard of this name. Okay, Haystack. So Haystack is nothing but it's a powerful open source. Okay, open source Gen AI framework. Okay, framework by uh, DeepSet. Okay, there is a organization I think called DeepSet. So they have developed this particular framework, and it was primarily used for the RAG application development. So primarily really used for building RAG application. Okay, retrieval augmented generations, and it supports various kinds of tasks like you can perform. So supports US system, then semantic search, then you can perform chatbots. Okay, and document search. Okay, so why we use Haystack? If we take a different color, okay, why? Because it has some amazing functionality. So here you can combine retrievers and reader in modular pipeline. Okay, modular pipeline. So those who have already used, I think they already know pipelines. Then second, plug and play supports for Hugging Face Faiss vector database, okay, even OpenAI, then Elasticsearch, then Pinecone, and Milvas. Okay, these are the things. And designed for production ready, scalable GenAI app, GenAI apps. Okay, so these are the actually, let's say, main things we have inside Haystack. That's why it is getting more popularities. And some core component wise, the core component wise, it has document store, then we have retriever, then we have reader, okay, and pipelines. Okay. So yes, guys, again, this is a like a orchestration framework you can consider. With the help of that, you can also build an AI application. Now, if I show you the documentation of Haystack, so Haystack documentation. So this is the website of Haystack. Okay, so here you can see this is the website of Haystack, and if you want to see the documentation of Haystack, this is the documentation. So here they have given the guideline, so how we can install the Haystack. Okay, Haystack AI. So how we can write the code, each and everything they have given. Okay, let's say you want to create the pipeline. So this is the example of pipeline. Even they have their own tutorial, you can also follow. Okay, so yes, guys, this is another framework you can use for GenAI application development. Okay. So most of the time we'll try to utilize the LangChain, because LangChain is having the ecosystem, and those ecosystem helps you to build most of the GenAI application with the help of LLMOps integration. So that's why we are not going to focus on Haystack, okay, or any other, let's say, orchestration framework. So most of the time we'll try to use the LangChain. Even nowadays people are using LangChain broadly. That's why, okay, we'll also try to utilize the LangChain. So yes, guys, I hope you understood what is Haystack, and thanks for watching. So guys, if you see the difference between your LangChain, LAMAIndex, and Haystack, so you can do some comparison, let's say, based on three kinds of, let's say, feature. So the first feature you can consider primary purpose. So what is the primary purpose of LangChain? So here, just let me write down. We're doing it for the LangChain. So the primary purpose is nothing but this framework is for building LLM application with uh, some tools, okay, and agent chaining. Okay, it has one chaining concept. With the help of that, we build the application. Then the second feature, you can talk about the core strength. Okay, core strength. So it has agents, memory, tools, chain, okay, chain of reasoning. And third, you can consider the ideal use case. Okay, ideal use case wise, multi tool agents, LLM apps, custom workflow. Okay. Yeah, now let's consider about LAMAIndex. Okay, LAMAIndex. So again, LAMAIndex, if you see the primary purpose, for building, indexing, structuring, and query. Okay, querying data with LLMs. Then second features, core strength, data connector, indexing, query engines. Okay, then we have ideal use, connecting private data. Okay, private data to large language model. Okay, like you can connect docs, API, SQL, and so on. Okay, now let's talk about Haystack. So primary purpose, end to end, SARS, UA. Okay, even you can also implement RAG and QA. Then second core strength, modular pipeline, for retriever, reader system. Okay, and third, ideal use case, document search, US system, and scalable RAG. Yeah. So these are the comparison you can do between the LangChain, LLMIndex, and Haystack. Okay, I hope it is clear, guys. So thanks for watching. Hi guys. In this video, I'll be talking about vector database. So here I'm going to explain what exactly the vector database is, how vector database works, and why you need vector database for the large language model. So first of all, let's try to understand what is vector database is. So you can see a vector database is a database used for storing high dimensional vectors such as words embedding or image embedding. So I think you know that over the internet, we have different unstructured data, right? Like we have images, PDFs, okay, documents, then we have something called audios. So if you want to store these are the data, you have to use vector database for that, right? So what we do, guys, we just try to convert these kinds of higher dimensional data to higher dimensional vectors with the help of some embedding model. Okay, and these are the vector we usually store in the vector database. Now you can ask me, why we can't store these are the vector to the traditional like database, like we have MongoDB, MySQL, right? I'll be explaining that part too. After like understanding that concept, I think your concept would be clear, right? So you can see, guys, over 80 to 85% data out there is unstructured data. Like if I'm talking about images, videos, text, okay, and audios, and we can't easily store them into a relational or traditional database like MySQL, then Postgres SQL, okay, then SQLite, or any other, let's say whatever database you are having. Why? Let's try to understand, okay, why we can't store these other data to the traditional traditional database, and why we need the vector database exactly. We'll try to understand each and everything.
So guys, to give you one example, let's take one image data as an example. So let's say I want to store these kinds of dog images to our relational or our traditional database. So if I want to store it, I can't directly store these are the data to our relational database. Okay. So if I want to store it, so what I need to do, I need to create some of the schema. Let's say I have some schema here. I have some table. So in this table, let's say I have one column called animal. Okay, animal. Then I have another column called color. Okay, then I have another column called tags. So basically you need to manually label them to store these are the images. Okay, if you want to identify similar kinds of images, if you want to apply the query on top of that, then you need to create these kinds of schema manually. Now here you just need to set those parameter manually. Let's say animal wise it's a dog. Okay, it's a dog. Then color wise, let's say it's black, or let's say I can, and color wise you can give any color, let's say golden. Okay, this is the golden dog. Then we have, let's say, black dog as well. Okay, black dog. You can give anything based on your image actually you are trying to store. Then you also need to assign some of the tags. Let's say this is very cute. Let's say this dog has black eyes. Okay, black eyes. So these are the tags actually we'll be assigning manually. So what happens actually, so whenever you assign these kinds of schema manually, so what happens, let's say you want to query the similar images, okay, from the database. So you just give these are the parameters. So it will return these are the images for you, okay, based on the tags actually you have written, based on the schema you have prepared, right? But again, it's a manual thing. Okay, it's not an efficient way to store our data, and it's not an efficient way to like query out our data, because let's say I want similar kinds of image, so I need to assign these are the labels manually, and it's like very hard task for us, right? So that's why actually we can't use our traditional, or let's say relational database for these kinds of unstructured data. We can easily use these kinds of relational database for the structured data. Let's say we have CSV data, we have Excel data, but for these kinds of unstructured data, it's like very much difficult to store these kinds of data, right? You can store them, there is no issue, but the thing is, like, whenever you will be querying out from your database, let's say you want similar kinds of dog images, at the time it would be very much difficult, because if I, let's say, convert this image to base64 string, so using base64 string I can easily store the data to the relational database. But I'm talking about whenever, let's say, you are applying query on top of that, let's say you want similar kinds of dog images from this database, at that time it would be very much difficult for you to querying out, because it doesn't know like whether this base64 string is a dog image, or let's say it's a cat image, or let's say it's a horse image. Okay, it doesn't know. So there is only one option to filter out these kinds of images. The thing is, like, you need to create one manual schema, like these kinds of tags you need to generate, you need to label out these are the images. Using that, actually you can filter out these kinds of data, but again it would be very hard approach, as I already told you, because you need to apply manual observation here. Now guys, I think you already got the idea, like why it is difficult to store these kinds of unstructured data to the relational database, because as you can see, image is nothing but it's a pixel, and your relational database doesn't ever know like how to query out similar kinds of images using these kinds of pixel, right? So guys, this is the one major problem with these kinds of relational database whenever we are using unstructured kinds of data. So guys, whenever I'm talking about unstructured data, it is not only image data. So it can be video data, it can be text data, and it can be audio data as well. So guys, to overcome this issue, there is a concept introduced called vector embedding. So let's say we have unstructured data. Let's say we have image, we have text, and we have audios, and it can be also videos. So first of all, what we need to do, we need to apply something called embedding model. Okay, so embedding model is nothing but it's a neural network based model. It's a deep learning model. So using this embedding model, first of all, you will be generating some of the embeddings, or let's say vectors. Okay, let's say this is my image. we have applied embedding model. Embedding model will give you vectors. Okay, like this is the representation of the image. Okay, this is the numerical representation of this image. It can be also applied to the text data. So you see here I'm giving the text data, and this is my embedding model, and it is returning this kinds of vector. Again, you can also put audio data, so it will convert to the numerical representation, and this is the representation of the audio. So here if you see, embedding model is nothing but it's a neural network based model. Here you can use any kinds of embedding model. Let's say we have what to wake, then we have transformer based embedding model as well, right? So these are the things actually you can use. So if you're already familiar with NLP, that means natural language processing, I think you have heard of like what to wake, then you have heard of like transformer embeddings. Okay, and nowadays actually we have large language model based embeddings, like we have OpenAI embeddings, we have lots of open source LLM based embeddings as well. We have Hugging Face embeddings as well. So using these kinds of embedding model, we can easily generate these kinds of vectors and we can store them in a vector database. So guys, this is the entire idea on top of this unstructured data, like how we can store these kinds of unstructured data to the vector database. So first of all, what we are doing, we are just trying to convert these are the unstructured data to the vectors, vector representation. Then we are storing these are the vectors, okay, to the vector database. So guys, here is an example you can see. So let's say we have text unstructured data, and here you can use any kinds of embedding model. So in this case, actually, I have referred this OpenAI embedding model. So it is already trained on GPT model, okay, GPT 3 and 4 model. And if you put these kinds of unstructured data to the embedding model, it will give you these kinds of vector, okay, this kinds of vector representation of all the text actually you have in the documents. Then once you got this vector, actually this vector embedding, then you will be using some vector database. It can be anything, any database you can use. So here you can store one by one, these are the data. Okay, so this is the complete idea of this vector database. Like instead of directly storing our text data to the database, first of all, what we are doing, we are taking help from the embedding model, and using the embedding model, we are trying to generating these kinds of vector embeddings. Then we are storing these kinds of vector embeddings to the vector database. And guys, this kinds of vector database has one beautiful function called similarity search. So using this similarity search functionality, it can return you similar kinds of vector represented in the vector database. Okay, I will show you this similarity search as an example, like how it is doing actually similarity search. Now guys, you got to know like what is embedding, but you don't know like how these embeddings are generated. So to give you one example, I will open my whiteboard and there I will try to make you understand. So guys, I'm inside my whiteboard, and here first of all what I will do, I will take one pen, and here I'll be using unstructured data, unstructured data as text data. Here I'll be using text data to give you the example. So first of all, what I will do, let's create one table here. So let me create one table. So guys, let's say I have taken one table here. So here we are using one embedding model. So let's say we are using one embedding model to convert our text to numbers. So here you can use any kinds of embedding model. You can use OpenAI based, you can use what to wake, you can use large language model based, you can use anything here. Okay, now whenever let's say I have some words here. So let's say I have something called king, then I have something called queen, then I have something called man, and I have something called woman, then I have some let's say monkey. So let's say I have 5 words here. Now what this embedding model will do, it will try to generate some of the features on top of the words. Okay, let's say this is my feature column, features column. Okay, so what kinds of features actually it will generate? Let's say it can generate anything. Let's say it can generate gender, it can generate wealth, it can generate power. Because this is a neural network based model, we can't say like what are the features actually it will generate, because it will generate these are the features based on the back propagation. So it will calculate the loss and all. Based on that, actually it will try to find out the best possible features, okay, for these kinds of work. So here I'm just giving one example, that's why I'm taking these are the features, okay, but it might not like generate these are the features, but to give you one example, I will be using these are the features. Now let's say it will generate weight, and it can also generate something called speak. Okay, now what happens actually, based on the features, actually it will assign some of the value. Let's say here my first word is king. Okay, now king has gender or not. Yeah, king has gender, and the gender is like male, so it would be 1. And for queen, yeah, queen has also gender, so it would be 0 because queen is a female. So similar wise, man has a gender, so it will have 1. And woman also has gender, so it would be 0 because it's a female. And monkey, let's say it's a male monkey, so I'll assign it 1. Okay, now it will come to the next features called wealth. Okay, now here you can see king has wealth, right? Because he's the king and he has lots of wealth, so it would be, let's say, 1. I'll assign it as 1. Queen will also have wealth because queen is also part of king. And man will also have wealth, but it would be less than king and queen, so let's assign as 0.5. And women will have also wealth but less than man, so here I can give 0.3. Monkey doesn't have any wealth, so I'll give as 0. Okay, now king has power, so I'll give 1. Queen has also power but less than king, so I'll give 0.7. Man has also power, let's say man has power but it's less than king, so I'll give as 0.5. Woman has also power but it's less than man, so it would be 0.2. And monkey doesn't have any power, so I'll give as 0. Now weight, yeah, king has also weight, so I'll give 0.8. And let's say king is a little bit obese. Queen has also weight, so I'll give as 0.5 because let's say queen is slim and all. Man has also weight, so I'll give it as 0.7. Women has also wealth, I'll give 0.5. Weight is fine, I think. Monkey also has weight, let's say 0.3. Now king can speak, so I'll give 1. Queen can also speak, I'll give 1. Man can also speak, I will give 1. Women can also speak, I'll give 1. And monkey doesn't speak. Okay, so I'll give as 0. Okay, now see guys, beautifully it has generated, these are the vectors. Okay, by generating these are the features. Now let's say if I want to represent king. Okay, if I want to represent king, so what would be my king vector? So here, this is your king vector. So king vector is nothing but 1 1 1 0.8 1. So this is the king vector. Now if I want to represent queen, so this is my queen vector. So queen vector would be 0 1, then 0.7 0.5 and 1. Okay, now if I want to represent man, so this is the man vector. So 1 0.5 0.7 and 1. Okay, now let's say if I want to represent women, okay, I think you are getting it, like how we have generated, these are the vector. Now this is the vector of the women, so 0 0.3 0 0.3 and 0.2 0.5 and 1. Okay, now let's take one 2D dimension, okay, and plot these are the vector and try to understand like what will happen. So let's say here I will take one 2-dimensional space. So let's say this is my 2-dimensional space. Okay, so this is my x and this is my y. So if you plot all the vector here, okay, if you plot all the vector here, you will see king and queen, king and queen will appear to the similar. So here let's say this is my king and this is my queen. Okay, so what will happen whenever you will plot these at the vector to the 2-dimensional space, or let's say 3-dimensional or any dimension, okay, you will see king and queen will appear like very close together. Because if you see here, okay, if you see here, as per the features, if you calculate the number, if you calculate a distance between these are the vector, you will see this distance would be like very less. Okay, that's why king and queen would be appearing very closely together. And here man and woman, let's say this is my man vector and this is my woman. Okay, this is my woman. So these two vector would be appearing closely. And here if you see here, there is another vector called monkey. Okay, monkey will appear completely different from these are the vector, because monkey is a different entity here. So let's say this is my monkey. Okay, now if I show you, see, so it has built one cluster. So this is one cluster, this is another cluster, and this is another cluster. Okay, now if you see here, using this concept called vector embeddings, we are easily getting these are the similarity score, okay, similarity vector. So now if I want to extract any kinds of vector, okay, let's say I want queen, okay, I want queen, so it will go to this cluster and will return this vector. And let's say not only queen, let's say it would be, let's say I want something called princess, okay, I want something called princess vector. So what will happen, it will come in this cluster, because if you calculate the vectors, okay, of the princess, you will see it will have these are the features, okay, it will have these are the features related to the king and queen, okay. So now this princess will appear here. So that's how actually this embedding model works actually. So it will first of all assign some of the features, based on that it will generate these are the vectors, and it will plot these are the vectors to the higher dimensional space. So here in this case I have taken 2-dimensional space, but it might be 3, 4, 5 and so on, okay, based on your dimension of the data. So whenever I'm using unstructured data, whenever I'm using real world data, so dimension might be vary, okay, it might be millions dimension, it might be 1,000 dimension, we can't say like what are the dimension it will have, but as a visualization we can only show 2D space here, okay. So this is the complete idea, guys. I think you got it, like how these embeddings model are working, okay, and how it is generating these kinds of vector, okay. Now here in this case actually you have lots of embedding models. So we have OpenAI embedding model, and this model is trained on GPT, okay, GPT model. I think you have heard of GPT model. Then we have something called Hugging Face embedding as well, okay, Hugging Face embedding. So it is already trained on, let's say, lots of open source LLM, okay, that means large language model. Then we also have something called Llama, okay, Llama 2 embedding. I'll be discussing like what is Llama 2 and all, okay, as a open source model. Then we have something called Google Palm embedding. So these are the open source embedding you can directly use. So this is from Facebook research, okay, and this is from Google research, okay. And this one is paid, because if you are using OpenAI embedding and OpenAI model, so you need to pay. This is completely paid, and these are the things are free, okay, these are the things are open source and free. But to get the Llama 2 access, actually you need to send some information, then they will give you the access. I'll tell you like how to take this Llama 2 access and all, okay, everything I'll be discussing about. Don't worry about, like, just try to stay with the video, I'll be discussing each and everything. So guys, I hope you got the entire idea, like how these embeddings models works, okay, and how it generate these kinds of embeddings as a vector, right? So guys, here I kept another example. If you just see this example, your concept will be very much clear. See here, I have these kinds of words, okay, and we are using these kinds of embedding model, and we are generating these kinds of vectors. And if we plot these are the vectors to the 2D dimension, so it will look like that. So let's say we have this 3 word, we have this 3 word, and we have this 3 word, and we are getting different vector. And this is the cluster, okay, this is the cluster of each of the words. If you see here, king, man, women, it's appearing in the same cluster. Then apple, banana, orange is appearing to the another cluster, and football, golf and tennis, it's appearing in the another cluster, because this is related to a person, okay, person, and this is related to fruits, and this is related to sports, okay, that's why this cluster is different. Now I think you got it, them vector embeddings, like how this vector embeddings looks like and how it is generating, okay. I have given you the entire idea. But one issue actually with this vector embeddings, which is nothing but whenever you are getting any similar kinds of vector, it is applying something called a distance formula. I think you have heard of like distance formula. We have Euclidean distance, okay, we have Manhattan distance, or let's say we have something called cosine similarity score as well, okay. So using these are the equation, actually it try to calculate the similar kinds of vector. But again, if you see here, it would be very much time taking, because it will calculate with respect to one by one all the vector, then it will give you the similar kinds of vector. So the main problem is like the time. If you are using this thing directly, so it will take lots of time to give you the similar kinds of vector. So to overcome this issue, actually they propose something called indexes in the vector database, okay, like we call it as vector indexes. So what is vector indexes? So let's say whenever we are having this kinds of unstructured data, we are applying this kinds of embedding model, and it is generating this kinds of embedding, okay. So on top of this embedding, where what is trying to do, it is trying to add some kinds of indexes, okay. So this indexes is nothing but it's a data structure. It's one kind of data structure actually. So what it will do, it will find out similar kinds of vector and it will assign some of the indexes. Okay, and it will make some cluster kinds of thing. So whenever let's say you have any new data, first of all it will see like which indexes actually it lies this data. So in that index only it will search that query. So to understand this, let's say this is my example. So first of all, let's say it has assigned these kinds of indexes. Now you have one new data. Now first of all it will see like which cluster actually this is lies. Okay, so it will go to that cluster, then it will return the similar kinds of vector with respect to the new data you are giving. Okay, instead of searching to all of the clusters. So this is the idea of these indexes in this vector database. Now using these indexes to our vector database, it's like very fast. Now whenever you are asking any kinds of query to the vector database and it is returning any kinds of vector, so this process time would be very fast. Now guys, I hope you got the entire idea like what is a vector database and all about, and what is embeddings and all about. Now you can tell a vector database indexes and store vector embeddings for faster retrieval and similarity search. So we used to use our traditional database to directly store our data, but in the vector database, first of all, we try to convert as vector, then we try to store them to the vector database. Okay, this is the complete idea. Now guys, let's discuss some use cases like why this vector database is useful, like what are the use cases are there. So as you can see, it will help you the long term memory for the large language model, because it is storing all of the data as a vector to the vector database. So whenever you are connecting these kinds of large language model to the vector database, so it can be used as a memory. Okay, memory of your large language model, like long term memory. And it can also perform something called semantic search. I already told you how to perform the semantic search using the formula and using the indexes and all. So search based on the meaning of the context. Let's say if you're giving something called, let's say, king and queen, so it will not only consider the text you are giving, it will also consider the context, like what is king, what are the features of king, what is the features of queen. Based on that, it will give you the similar kinds of vector, okay, as a output. Then it can also perform something called similarity search, as I already told you, like on the text data, image data, video data, or let's say audio data. Let's say I have one image, let's say dog image. I will tell hey, just give me some dog images, okay, similar kinds of dog images. So it will first of all try to see the vector, okay, similar kinds of vector, and it will return the similar kinds of representation of the dog to you. Okay, so we call it as similarity search. Then it can be also used in the field of recommendation system, because as you already saw, like if you are having these kinds of vector together, and it can perform similarity search. Let's say I want to build something called recommendation system. So let's say I'm asking for like food related content, so it will suggest me food related content only, okay, using these kinds of similarity search and all. So guys, this is the entire idea of this vector database, and these are the use cases actually you can consider, okay, inside this vector database.
So guys, here you can see some widely used vector database, like we have ChromaDB, Weaviate, Neo4j, then we have Faiss, we have Pinecone. Okay, apart from that, there are some more like vector databases are available, but these are some widely used vector database, okay, you'll be getting. So in our program also we'll try to utilize some of the vector database for implementing these kinds of LLM powered application. Okay, then I think your understanding would be more clear. So yes guys, this is all about our vector database concept. I think you got the entire concept, okay, why vector database is required. So with that guys, this is all from this particular video, and thanks for watching. Hi guys, in this video I'll be talking about Pinecone. So what is Pinecone exactly? Pinecone is a vector database for storing vector embeddings. So I think you know what is vector embeddings and what is vector database. So in our previous session, I was talking about the vector database, how vector database works, how we convert our data to the vector embeddings, and how we usually store them, okay, and why vector database is required. Each and everything I have clarified. So Pinecone is one of them. It's a famous vector database, and it is hosted over the cloud. That means all the vector embeddings you can store in the cloud, okay, cloud platform. I mean, Pinecone provides one cloud infrastructure, so there you can store your vectors, okay. Now you can see this is the website of the Pinecone. So just visit pinecone.io. So this is the official website. You can also search over the Google. You will be getting this particular link. Now you can see guys, they have their entire website. Even they have already written their demo, okay, whatever service they are having, everything they have given. So if you have time, just go through their website, you'll be able to understand. So first of all, what you have to do, you have to create one account here if you don't have the account. So for me, I already have the account. So what I will do, I'll just try to log in with the account. So if you log in with your account, you will be getting something called Pinecone console. Okay, so this is your Pinecone console, and by default you will be getting these kinds of console. Now I will show you how we can work with the Pinecone. I will show you one practical demo. After that, I think this part would be clear how you can store any kinds of documents or let's say vector embeddings to the Pinecone. Okay. So here the first thing what you have to do, guys, you have to create one Jupyter notebook. So here I already created one Jupyter notebook. So here I created a Jupyter notebook over the Colab, Google Colab. Okay. So here you have to install the Pinecone at the very first time. And how to install the Pinecone? This is the command pip install Pinecone. Even they have also given their tutorial. You can see the quick start tutorial. So you can also refer the tutorial and you can set up the Pinecone environment. So let me first of all connect my notebook. And all the resources should be available in your resources section. From there you can download. So once it is connected, now first of all install the Pinecone here. So Pinecone is installed. You can see this is the version. And now you can see this is the code to create the index in the Pinecone. And what is index exactly? See, index is nothing but it's a database. Okay, so here you have to create one database. In that database cluster, you will be storing all of your embeddings. Okay, embeddings vector. And how to do it? So either you can create it manually. So there is an option called create index. Either you can create with the help of Python code. And if you're using Python SDK of Pinecone, with the help of this Python code, you can easily create that. For this, you need a Pinecone API key, because with the help of API key, you will be able to let's say access your Pinecone account. And how to generate the API key? Just click here, API key. So there you will be getting one option called create API key. So here you can click and you can give the name. Let's say I will give demo. Okay. Now if I click here, so it will be creating the API key for me. So you can also visualize the API key. You can copy here. And here you can mention it. Okay, so I already created the API key, that's why it's visible here. Now what I will do, I'll just try to close. And if you want to delete any API key, let's say I want to delete it, click here and try to click on delete. And here you have to give the name of your API key. So this is the name. Now I'll delete the API key. Okay, now I'll go back to my instance database. Database means your index. Okay, so now let's create a database here. We will be calling as index. Okay, now how to create the database? So you can see, guys, first of all you have to import Pinecone, this Pinecone class from the Pinecone itself. Then you have to give the API key. So you can see I'm given the API key, so it will initiate. Okay, it will initialize the Pinecone and it will do the authentication. After that, this is the index name I'm giving. Now you can give any name here. Let's say here I've given dense index. You can give any name. Let's say I'll give something called any other name. You can give any name. Okay, and as of now I'm not giving any name. I'm giving as a dense index. Okay, you can give your name, my name, okay, your project name. Let's say you're creating a chatbot. Let's say you're creating a medical chatbot. So here you can give medical chatbot. Okay, it can be any kinds of name. Now once index name has been initialized, so then you have to execute this particular code. You can see first of all it will check whether this index is available or not. If not, it will create the index. Okay, you can see it will create the index. It will initialize the cloud infrastructure. So by default it will be using AWS cloud, and this is the region. And by default it has one embedding model called Llama text embed v2. Okay, so you don't need to use any OpenAI embedding model. Okay, previously if you see the previous version of Pinecone, we have to initialize the OpenAI embedding, but here you don't need to do. So it by default it has one embedding model. It will try to utilize that embedding model, and it will convert your vector let's say text to embeddings. Okay, then you have to also initialize the field map text chunks. Okay, so once you have let's say written everything, now if I execute, so you'll see that in your index it would be one new index would be created. Let me show you. So see, execution is done. Now let's get back to the console. Now if I refresh here, okay, if I refresh here, you will be seeing, see, the index has been created. The name actually I have given dense index, it has created, and you can see this green tick mark, that means it is running right now. Okay, now if you want to see that, just try to click here. You can see all the information, like it is using cosine matrix. This is the vector dimension 102524. This is the host URL. It is using AWS cloud. This is the region. Index type is dense, and you can see capacity mode and model. It is using Llama. Okay, Llama embedding model. Now as of now we don't have any records here. You can see record count is equal to 0. Now we'll try to store our vectors. Now she initially will be getting some free trial access. Okay, so you can store up to 2 GB. Okay, and this is the infrastructure actually you got. Apart from that, if you want to get more infrastructure, you can upgrade now. Okay, you can upgrade their, let's say, service. So if I click here, see, it will have a different let's say planning option. So you can upgrade, okay, as per your requirement. So unless and until you are not using it for the production, you don't need to upgrade. Okay, if you're using for the learning purpose only, I think free tier access is fine. Now what I will do, I will initialize the data. So you can see guys, this is the record I have created. So here I have some text chunks, okay, about the Eiffel Tower or any other, let's say, a category I have just mentioned. I think around 50 example I have here. Okay, you can see. And even I've also mentioned the category. This is the physics category, this is the geography category, this is the nutrition category. So different categorical data we have. Now you can load any kinds of documents from the PDF, from the documents, from the image, okay, anything you can load. Now let me initialize the records. Even I have also given one unique ID here. Now once it is done, now what I will do guys, I'll try to store these are the records to the Pinecone index. Okay, for this, first of all, you have to initialize the index name. So here you can see I have initialized the index name. Index name is equal to my dense index. Okay, so here I'm initializing that. Then after that, you have to upsert. Okay, upsert the records. So if you want to store anything, you have to use the upsert function. Now here you have to give the namespace. Okay, some naming convention you can give. So here I have given example namespace. You can give any name just to filter out your data. Now here you have to give the record. So the record you have. So this is the entire record. I'm passing it here. Now if I execute, it will store all the data to the Pinecone index. Now if I get back here, now if I refresh, you'll see that it will store all the data. See, okay, all the 50 records has been updated. Now it is also visible here. So sometimes it takes time to get the update. Okay, even they have also mentioned in their documentation, you have to wait for some times, then you'll be able to see that. You can see ID, category and text. Now you can see the score, okay, like the semantic score, like what is the score of this vector, okay, what is this vector store of this vector with respect to all the vector. You can see all the score here. Now if you want to see the embeddings, what you can do, you can click here and you can click on fetch. Now here you will see this particular value, and this is nothing but your vector embedding. Okay, and this thing we usually pass to the large language model. You can also edit the records. Okay, if you want, you can also edit the records. It is also possible here. Now this is one of the amazing vector database guys, because here you can visualize your vectors and all the things are interactive, and it is hosting your let's say embeddings to the cloud. So that's why I personally like Pinecone a lot. But if you want to let's say store your embeddings to the local data, let's say local store, that time you can use Faiss, ChromaDB, okay, or any other vector database, which I'll also discuss, okay, going forward. Okay, so now you can also filter out with respect to the dense value, with respect to the text. Okay, even see the namespace we have given, it is also visible here. So this is the like filtering option. If you want to filter your records, you can also filter it here. Now guys, we have successfully stored our vector. Now we'll try to see how we can do the semantic search operation. But before that, let's say you don't want to open the console and you don't want to see like how many records you have and what are the, let's say, metadata you have. For this, you can execute this particular code. This particular code, what it will do, it will see the status of your index. Now if I execute, you'll see that it will extract all the status, all the metadata, like how many records you have, what is the type of that, everything it will show you. But before that, I'm giving one time because you have to wait for Upsert. Okay, let's say you have executed this code, and sometimes you have to wait let's say 10 to 12 seconds. Okay, sorry, 10 to 20 seconds. That's why we are given one timer, because it takes a little bit time for the upgrade operation, okay, in the index. Now see guys, this is the dimension of the vector, this is the index, okay, that many of record you have, so everything it is showing you as a code. Now we'll try to do the similarity search operation. So this is my query, let's say famous historical structure and this one monuments, okay, monuments. Now here you can see I'm doing the search operation, index.search. This is like naming space, okay, you can see this is the name space I'm giving. Top k, that means top records, it will show me top similarity score, it will show me 10, okay, 10 records it will show me. And this is the query I'm passing. After that, whatever results I'm getting, I'm just looping through it one by one. Now if I execute, now okay, see guys, this is the 10 similar results I got. Okay, 1 2 3 4 5 6 7 8 9 10. Okay, now you can see also the score. This is the ID and this is the text name. Okay, so that's how guys we can easily store our vectors to the Pinecone, and we can do the similarity search operation. Okay, I hope you got it. So yes guys, this was the entire demo of our Pinecone. Now you can try, you can use your documents, you can store to the Pinecone index, and you can create some amazing application with that. And you can also consider this is one of the LLMOps tool, because at the end you are optimizing the, let's say, application performance whenever you are storing besides the vector to the vector database, and you are connecting the large language model there. So that means you are optimizing the entire application. Okay, so yes guys, this is all about. I hope you liked it. Thank you so much. Hi guys, welcome back with another video. So guys, in this video we'll be talking about another vector database called Weaviate. So Weaviate is also a cloud based vector database. So here also you can store your vector embeddings to the cloud, and it is also a like premium vector database. Here you have to also take the subscription, but if you're using for the first time, they will give you some free credits. So here guys, first of all, what you have to do, you have to create one account. Just click on the try now button, and there will be getting one option called sign up. Okay, sign up button. Just try to click on the sign up and try to create one account with the help of your email address. Okay, once you have created the account, now I'll show you the demo. Okay, practical demo how we can store our, let's say, embeddings to the Weaviate platform. So all the practical demo I'm going to show you, and all the resources guys I'm going to share. You can check the resources and you can try it, okay, from yourself. So now guys, let's see how we can use the Weaviate, okay, to store our vector embeddings.
So here, first of all, you need to install some of the libraries. So these are the libraries are common. So guys, here now I'm using something called Weaviate. So this is the like Python package like Weaviate client. So you need to install this package to connect with your Weaviate, okay, Weaviate cloud database. Now let me just quickly set up them. Now guys, what to do, you need to collect some of the credentials. So these are the credentials are required. So first of all, I need my OpenAI API key. Then I need my Weaviate API key and Weaviate cluster, okay, cluster URL. So this three thing actually I need. So I think we already created my OpenAI API key. Just try to copy from my previous notebook. So here is my API key. So I'll just copy. And here I will just try to paste it. Okay. Now let's see like how we can collect this Weaviate API key. So for this, just visit your Weaviate dashboard, and here just try to create one cluster. Just click on create cluster. Okay, you need to give the cluster name. So let's give any name. So I'll give test. Okay, so you can give any name. So everything will remain same because this is a free one, and it will expire in 21 days because this is the free version, free tier I'm using. Okay, but if you want to use for your production grade applications, at that time you can take the subscription. Okay, now just try to create the cluster. So it will take some time. Once it is ready, so it will give you the status message. And guys, if you see, Weaviate also support these kinds of client like Python client, Java client, CLI, TypeScript, then Go. So it has actually multiple client support. So like those are working in Java and all, so you can also use it. Now guys, see, my Weaviate cluster is ready. Now if I click on detail, now here it should give me that detail of my cluster. Now here, first of all, I need to copy this cluster URL. Okay, just copy this cluster URL here. From here you can also copy. Now let's go back to my Weaviate, and here you need to paste it. Oh sorry, this is my API, so I need to paste it here. This is my cluster URL. Okay, now I also need to copy the API. So here is the API option. Just click here, and this is the API key. Just try to copy and don't share. I'll delete it after this recording, so that's why I'm sharing. And I'll just paste it here. Okay, now I got my 3 credentials. Now let me execute them. Okay, so first of all, I need to read my data. So let me read the data. So here, first of all, I will create one directory called mkdirs data. Okay, now data folder has been created. Now inside that I will upload one PDF file I have here. So this is the YOLO paper, actually YOLO related content. So you can download any kinds of PDF and you can upload here. No issue with that. You can either use text data, okay, doc data, it's up to you. So guys, as you can see, my PDF has been uploaded here. Now what I will do, I'll just try to load this PDF, okay, and I'll just extract that text from it. So let me show you like how this PDF will look like. So guys, see, this is the YOLO like presentation, okay. So I have downloaded as PDF. I'll just execute this particular code. So here I'm giving the data directory and I'm telling just load the PDF file, okay. Then I'm loading the data. Now let me load. So it's giving one error. It's telling unstructured package not found. Please install it with pip install unstructured. Okay, so what is happening actually? So if you see here, I have downloaded this Google, like you can say slide. Okay, Google slide as PDF. That's why it is considering as unstructured PDF. Okay, so that's why we need to install one package called unstructured PDF. So let me install it. So this is the command to install. But if you are having like PDF, like very simple PDF, so you don't need to install it, okay. So this is for like unstructured PDF. So if you have any complex PDF, so you need to install this package. So previously I was using like paper and all, okay, that's why it was simple PDF, but now I'm using like Google slide PDF, that's why it's giving this error. And it's pretty good, like it will tell you like what are the packages you need to install and all, so it will give you the message as well. So guys, it's done. Now it's telling just restart the runtime. So let's restart our runtime. Okay, now let me execute this code. Now it is extracting all the text from this PDF. You can also upload multiple PDF here. It's up to you, but I have already added one PDF. I just want to show you the quick demo. Done. Now let me show you the data. So guys, this is the entire data I got from my PDF, okay. Now I need to apply something called text splitting. I think you remember. I need to convert it to chunks. So let's convert it. So recursive character text splitter, okay. I'm importing from LangChain, and this is the chunk size and chunks overlap. You can give any number here. So let me just do it quickly. Now I got my chunks. Okay, see, this is my chunks, and also let me see the length. See, all the things are common only. We are just changing the data database client. Okay, like I'm using ChromaDB, Pinecone, and Weaviate. So just client is changing, but steps are same. I think you are getting. Now I need to convert to embeddings. So let me just comment it out. So here I'm going to use OpenAI embedding. OpenAI embedding, and here you need to pass the OpenAI API key. If you're not passing, it's fine. You need to add inside the environment variable. So previously we added, if you see here, environment variable, but here I'm not adding environment variable. If you're not adding inside environment variable, you can directly pass them. Okay, that will also work. Okay, it's giving error. OpenAI is not defined because we have restarted the runtime. So I need to execute this cell again. Now I think it should work. Now here I'll be initializing my Weaviate vector database. So if you visit Weaviate documentation, there is the documentation, and here they have given the installation guideline, then configuration, then what is the schema, libraries, everything they have explained. Okay, so you can visit the documentation and you can get all the information. But here I already gone through the documentation and I prepared this notebook. So this is the code actually you need to write to initialize your Weaviate actually. That's why actually I like Pinecone one, because Pinecone looks easy to me, because what I feel like Pinecone is like more easy, and it's like more easy to understand and like more clear. But if you're using Weaviate, so you need to write some extra code it, okay, but it's completely fine. Okay, no issue, you can use it. I will share my notebook. You can use this notebook as it is. So here I'm just first of all importing Weaviate from LangChain. You can also import directly, it is also fine. Now here you just so first of all you just need to connect with your Weaviate cluster. Okay, this cluster we have created here, I think you remember, this is the cluster. So to connect with the cluster, you need to give the API key, Weaviate API key, and I think you know we already collected the Weaviate API key here, and I stored in the variable. Okay, then I also need collected the cluster URL. Okay, both I have collected. Now cluster URL you also need to give, then you need to initialize the client, and inside that you need to give the cluster URL and as well as the OpenAI API key also, because using the OpenAI API key, it will use the OpenAI embedding. Okay, whenever it will convert your data to vector embedding, so it will use that OpenAI embedding. Okay, so that's why you need to give the OpenAI API key here. Now I also need to give something called authentication configuration. So this is the authentication configuration, which is nothing but my API key, Weaviate API key, and this is the startup period. These are some default parameter you need to give, and let's execute. Okay, now if you want to check it whether this client is ready or not, so this is the code for it. So is ready. So now it is true. That means my client is ready. Now it is connected with my Weaviate client. Now Weaviate is telling you need to prepare something called schema. Okay, here they have given one client schema. So if you visit this client libraries, okay, so here if you see example client schema, so you also need to define some schema here. Schema is nothing but it just it kinds of configuration it will take, okay, as input. Like you can change the configuration with the help of code. So that's why these are the things they are giving. But if you're not able to get it, okay, it's completely fine. So you just need to give this schema and it will come on for every experiment you'll be doing. So this is the complete schema, guys. Okay, so client schema detail. First of all, if it has any schema, it will delete, then it will add this schema. So here you can give any name. Okay, so I have given chatbot here. Then here you can give any description. Then what are the vector actually model you are using, you can give the name here. So in OpenAI actually you have ADA model. Okay, so here I'm using ADA model. I think you remember. If I print my embedding, so here I was using something called ADA model. Okay, as you can see here I was using something called text ADA embedding ADA model. So that's why you can also give the name, and these are some description you can give, and after that you can create the schema and you can create your client. Okay, now this is the code, so you can execute. And this thing is not required in Pinecone. So Pinecone can handle these are the thing automatically, but in Weaviate you need to provide. That's why I personally like Pinecone. Okay, now once it is done, you need to initialize the vector store. Okay, so now this code will initialize the vector. So what it will do, basically it will take your documents. Okay, I think you remember we have created the documents. Okay, we have created a cluster, and from this cluster with the help of this embedding, we are just trying to generating the vector and storing inside our Weaviate. Okay, now let me execute and show you. Now see guys, now if I go to my Weaviate and refresh, now it hasn't updated yet. So after some times you will see it will update, like how many embeddings had generated. Okay, then how many times you have you can say did the request, everything it will show you here. Okay, so all the information actually it will give you, and these are the, and guys, these are the embedding model are available by default with this Weaviate, so you can use any of them, it's completely fine. But we are using this ADA model, OpenAI generative model. Okay, so yeah. So guys, usually it takes some time, around 5 to 6 minutes. After that you will able to see all the update here. So in between what I can do, I can show you the other step. Now we have successfully stored our embeddings. Now let me just do the similarity measurement, that means similarity charts. So here first of all I will ask one query called what is YOLO, because this is the YOLO related content, and here I'm initializing this similarity charts. Okay, because the vector store is this is my object, and on top of that I'm just writing similarity charts. Here I'm giving the query, and top k, that means how many output you want to get. So here I'm given 20, you can give any number. Now it will return like 20 results. Okay, 20 similar kinds of results. See, okay, but I can't actually take the answer. So what I can give one chain with the help of LangChain. So here there is another parameter called question answering. Okay, load QA chain. You can also use this chain. Otherwise, you can also use retrieve QA chain. Okay, that is also fine. Now here I'm going to use OpenAI LLM. Now I'll define my chain, and here I need to pass my OpenAI API key, and this is the chain type. And temperature means like if temperature is 0, so your model would be like more you can say stick to the answer, like it won't be giving any randomness. And if you're changing the temperature to close to 1, so it will give some random output as well. Okay, so this parameter you can change. I think if you have learned like LLM, so I think you know this parameter and all. Okay, so these are like basics thing, okay, in LLM. Now let me define my chain. Now here I will ask this query. So change the run input documents. So this is my documents. This is my entire documents I'm giving. Okay, the documents I have, and see, this is the documents. That means I got all the answer, right? 20 answer, and from this 20 answer I want my query. That means the query I'm asking, which is nothing but what is yellow. So now with the help of my LLM, I will get my authentic answer. See, yellow is an algorithm for object detection that is unified, real-time, and has higher accuracy. It is presented by Shivang Singh, and this is the date of the publication. Okay, so yes, I'm getting my output and all. So now you can ask any kinds of question about yellow and all. Okay, I think you got it. Like I already showed you multiple time. You can either create one while loop and you can ask many question here.
Hi guys. In this video, I'll show you the Faiss vector database. So Faiss is another amazing vector database developed by Facebook. So here, this vector database is also a local vector database. That means it will also store your vector embeddings to the local storage. So this is the documentation of Faiss. You can refer the documentation. They have given the entire installation process and everything. You can refer it. So what I'll show you guys, I will show the practical demo how we can use this particular Faiss vector database. For this, let's open up a Google Colab notebook. Then here I will just give the name, let's say Faiss demo. Okay, and I will just try to connect the notebook. So first of all, you have to install the Faiss. So to install the Faiss, guys, this is the command. So pip install Faiss. Okay, Faiss CPU, and I also need the NumPy package. Okay, so let me install them. Then once it is done, I also need the OpenAI. So let me also install OpenAI. So pip install OpenAI is equal to I'm going to install one specific version. That's 0.28. So once it is done, I'm going to import some library. First of all, I'm going to import Faiss. Then I need OpenAI. I need NumPy. Okay. So let's import all of them. Then I'm going to initialize the OpenAI API key. So to initialize the OpenAI API key, just write OpenAI dot API key API underscore key. And here you have to pass the API key. Let me give my API key. This is my API key. So now what I will do, I'll just try to initialize. Okay. Then here I'm going to write a function. This function will return you the embeddings. Okay. That means here we'll try to use the OpenAI embedding model to generate the vector embedding. So here, this is the function. This is the function, guys. Get embedding. So it will take the text and it will initialize the OpenAI embedding model. You can see text embedding add a model, and it will return the embeddings. Okay, we as a NumPy array. Now let me initialize it. Okay, so once it is done, I'm going to also initialize one example text. So let's say this is our example text. Okay, you can use any documents, whether it's a PDF, whether it's a documents, anything you can use. So here I have written like Faiss is a library for efficient similarity search. Okay, it's developed by Facebook AI Research and blah blah blah. Okay, this thing I have written. Now first of all, I have to get the embeddings. So to get the embeddings, I can use this code. So here I'm passing this text to the function. Okay, and this function will return the embeddings. Okay, one by one you can see I'm calling this function, and here I'm running a for loop. So it will loop through one by one, and it will pass the text, and this will return you the embedding. Let me show you. So if I show you the embeddings right now, so this is the embeddings I got, guys. Okay, now what you have to do, you have to normalize if you want to perform the cosine similarity. Okay, only for cosine similarity you have to do the normalize operation. And how to normalize? Faiss has already one function, normalize L2. Okay, we are doing the L2 normalization. Now normalization is complete. Then we have to create the Faiss index. For this I have to get the embedding dimension. So how to get the embedding dimension? So this is the code for that. So embedding.shape.1. So this will give you the dimension. So this is the dimension of the vector. Now let's create the Faiss index. Okay, so here we'll try to create the index. Faiss index plat IP. Okay, and I have to give the dimension, so it will create the index. Okay, index has created. If you see the index object, see it's created one object. Now guys, see again, I told you, so this is a like local vector database. Okay, it will create the index in your local storage. Okay, you can see in the memory. Now we'll try to add the embeddings to the index. So here you have to use the add function, and whatever embeddings I generated here, I'll just try to store them. Okay, store is complete. Now I also need to store the original text ID. So for this is the code. So here we are enumerating over the text, and we are adding one ID. Okay, so you can see this in the this is the ID. Okay, that means this is the first, this is the second, this is the third, and this is the fourth. Okay, that's how. Now we can perform the query operation. So let's say this is our query. Okay, so what is Faiss? So first of all, we are getting the embeddings of that text. Then we are we're doing the normalization. After that, we'll do the search operation. You can see we are getting two similarity search results. Okay, so here index.search, we are giving the query vector, and we are reshaping the results, and we are getting the k parameter, that is 2 output. Now if you want to see the output, you can run a for loop to display that output. So see guys, this is the first one and this is the second one. Okay, you can see based on this particular question, these two results are similar. Okay, you can see this is the score, highest score. So yes guys, that's how we can use the Faiss vector database, and you got it. Now you can use any kinds of data, and you can reuse this particular code, and you can do the experiment. So yes, I hope you got it guys. Thanks for watching. Hello guys, welcome back with another video. So guys, in this video I'm going to discuss about another amazing vector database called ChromaDB. So ChromaDB is the local vector database. That means you can store your vector to the local storage. Okay, so this is the website of ChromaDB guys, you can see. Okay, and how we can use this ChromaDB. So they have one amazing documentation. You can also open the documentation. Okay, and you can also refer each and everything. So let me show you the practical demo how we can use this ChromaDB. Then I think your understanding would be more clear. And all the resources I'm going to share, you can download and you can also try from your end. So let's see the demo of ChromaDB.
So guys, as you can see, my notebook is connected. Now, if you want to test it, whether it's working or not, just write one message here. So I'll just write print. Okay. So it should, yeah. So it's working fine. Okay. So now the first thing, I'll be installing some of the like required packages. Like I need to install the ChromaDB and all. So there is the guide actually. They have given like you need to use pip to install the ChromaDB, and how to like set the client and all, everything they have given. Okay. So first of all, what I will do, I will just set up this ChromaDB. So to set up the ChromaDB, you will need some more required package. Okay. Some more dependency. I'll tell you like what are things you need. So just write pip -q install. First of all, I need something called ChromaDB. So I'll copy the name from here. ChromaDB. Then I need something called OpenAI, because I'm going to use OpenAI embeddings and OpenAI, like you can say LLM model. Okay, that means GPT 3.5 turbo model. So that's why I need OpenAI. And I also need something called LangChain, because I told you I'll be using LangChain here. LangChain, and there is another dependency you need, something called tick token. Okay, tick token. So if you are using OpenAI embedding, so you need this package actually, tick token. Now, yeah, I think these are the things actually I need. Now let me install it. And guys, you need OpenAI account for this video actually. So just try to create an account here. Otherwise, you won't be able to do it, because you need the OpenAI API key, okay, to run this, like you can say notebook. So guys, installation is done. Now, if you want to see, let's say any version of any package, so what you can do, let's say I want to see the ChromaDB version. So I'll just copy the name, and here you can just write pip show. Pip show, and just give the name of the package. Now if you execute, it will show you the version and every information about this package. See guys, name is ChromaDB, and this is the specific version, and this is the entire summary of your like ChromaDB package. Okay, so that's how you can see for all the packages, okay, you have installed. Now here first of all I need to download some data, because here I'm showing you vector database example, and there actually I need the data, okay, to show you like how to store and all. So for this actually what I will do, so there is a actually this Dropbox links, actually you can see this is the Dropbox links, and inside that actually you have some article data. If you see Google article is there, then you have some AI startup article, Amazon article, then you have Databricks article, ChatGPT article. So we have different articles here, okay, and this is a txt data, txt format data. Now if I open any kinds of txt file, see this is the article related to this default, okay, generative AI. So they have written all the article and all, okay. So I'll be using these kinds of data. You can use any kinds of data, it's up to you, but this is the open source data actually I got from the internet, and this is the link of the data. So to download this data, first of all I will copy this link, and here I'll be using something called wget to download this data. So I'll just write wget. So wget is a Linux command, and here we are using Google Colab, and Google Colab is running on the Linux operating system, okay. So it is running on the Linux kernel, so that's why you can execute any kinds of Linux command here. So here I'll just write wget -q, and here I'll just paste this link, okay. I'll paste this entire link. Now once it will download, let me show you how it will download. So if I execute this cell, left hand side you will see it will download that zip file, okay. See new article.zip file, this zip file has been downloaded. Now I also need to unzip this zip file, so I'll just write unzip -q, and this is the name. I'll just copy the name. I'll just copy the name, and here I'll just tell the directory like where you need to unzip it. So I'll give the same name. So this is the name, new underscore articles, okay. So it will create one folder, new underscore articles, and inside that it will unzip everything, okay. Now if I show you, it's done. Now if I refresh the page, I think inside new articles, now see guys, all the articles are present, okay. Now let's see if you want to open it, you can also open and see. So this is the article and all about. So now let me close this thing. So we have successfully downloaded our data. Now what I need to do, I need to first of all create one OpenAI API key, and I'll be setting up my environment, okay. Give a comment here, setting up environment. And don't share this key with anyone guys, otherwise they will also able to access your like you can say OpenAI account. I will be removing these keys after this recording, so that's why I'm showing. Now here first of all I will import operating system package called OS, and here I'll set the environment. So I'll just write os dot environment, okay. And here you just need to give the keys like which name you need to save it. So I'll just give OpenAI underscore API underscore key, and equal to, I'll set my API key here. So this is my API key. I'll copy or I'll cut it, and here I'll set it. Yeah, that's it. Okay, now I can remove this cell. Now let me execute. Done. Now I need to import some of the necessary libraries. So import. So first of all, I need to import something called Chroma. Okay. So if you're using LangChain, so LangChain already has this Chroma API, because I already told you the integration. So it is the integration with the LangChain as well as the LAMAIndex. So instead of like importing directly, like import Chroma, okay, import Chroma, we have to import it like from the LangChain itself, because here I'm going to use LangChain framework, okay, to build my application. That's why I need to call it from the LangChain. But let's say if you're using it for any other like task purpose, let's say you are not creating any generative AI application, let's say you are doing some different thing, okay, different application, at that time you can directly import it, and all the functionality will remain same only, all the code will remain same only, you just need to change the import, okay, at that time. So here I'll be using LangChain, so I need to import it from the LangChain itself. So how to import it. So just write from LangChain dot vector store. So there is a function you will get called vector stores import. So I'll import my chroma. So I'll just write chroma. Then I also need to import uh, OpenAI embedding, because I think you remember. Let me open my board. I think you remember, first of all, what I need to do. Let's say I have my unstructured data. So let's say this is my data. So the first place what I need to do, I need to use something called embedding model. Embedding model. So this model might be anything. So in this case, I'm going to use OpenAI embedding model. OpenAI embedding model I'll be using. So you can use any model here. Okay. Then after that, it will return me my vector embedding. Vector embeddings. Okay. And that vector embeddings I will store inside my vector database. Okay. Vector DB. So in this case, I will be using something called ChromaDB. Okay, so this is the complete idea. So first of all, I need to import this embedding model as well. So here I'm going to use OpenAI embedding, so I can directly import OpenAI embedding. So let me do it. So here I'll just write from LangChain dot embeddings import OpenAI embeddings. OpenAI embeddings. Okay. Then I also need to import OpenAI, because I'm going to use OpenAI large language model. So again, I'll just write from LangChain dot LLMs. That means large language model. I need OpenAI. Then I need to load my data. As you can see, this is my data and it is present inside a directory. Okay. And again, this data format is a TXT data. Okay. If you see, it's a TXT data. So for this, I again need two libraries. So I'll just write from LangChain. So guys, I'm expecting you are already familiar with this LangChain, because if you check our YouTube channel, so we have already covered this LangChain tutorial and all. Okay. So you can go with that tutorial and you can learn the LangChain. So here from LangChain, there is a class called document loader. So just write document loaders. Okay. So first of all, I'll be import something called directory loader. Okay. Directory loader, because my data set is present inside the directory. That's why I need this directory loader. Then I also need to load my text loader, because it's a TXT data, right? So I'll import the same thing only. Sorry, it should be data loader, I think. Document loader. It's a document loader. Okay. Now it should be text loader. Text loader. Okay. Yes. So as of now, I need, these are the libraries, and if I need anything, I will be importing later on. So let me just quickly import them. Now we'll be loading the documents. So load data. So guys, to load the data, just write directory loader, and inside that you just need to mention the directory. So here, this is the directory. I'll just copy the name, copy path, and I can give it here. So this is the directory, and inside that actually I have txt data. Okay, I have, if you see, I have txt data. So I only want to load the txt file. So if I, let's say I have some any other file, okay, I will be ignoring. So for this, there is a parameter you can give called globe. Okay, just write globe equal to, so it should be txt file. So all the file just load. Star means all the file. Okay, it should be dot txt. Then you also need to define the loader class. Okay, so just write loader class, and it should be my text loader, because all the file are txt format. Okay, that's why you need to give this text loader. Okay, now it will load up your data, and I'll be storing this data inside a variable called loader. So this is my object of my data loader. Now let me execute it. Now to load the data, you need to call one function called loader.load. Okay, if you call this function, it will load the data, and this data will store it in a variable called document. Okay, and see guys, it will load all the data inside this document. See guys, this is the all of the text actually you can see here. So it has loaded all the txt file one by one, and it has extracted the data, and this is your entire data as you can see. So let me show you. See guys, and this is a document object. Okay, this is a document object. Now we have successfully loaded our data. Now guys, before converting this dataset to the embedding and storing it to my ChromaDB, first of all, I need to apply something called text splitter on top of it. Basically, I need to convert my entire data as a chunks, because as you can see, this is my complete corpus. Okay, see, this is my complete corpus. If I show you, so if I show you the data, see, this is the complete data. Okay, this is the complete data corpus. But this data set is like very huge. Okay, I can't like you can say directly convert it to vector. Okay, so if I'm converting, so what will happen? Okay, let me explain. So what is the use of this chunks? Okay, so see, so whenever you are using any LLM model, okay, whenever you are using any LLM model, so it has one input size. Okay, it has one input size, as well as it has one output size. Okay, output size. So whenever you are giving something as an input to the LLM, okay, you need to always take care about the input. Okay, so I'll tell you like where you need to check the input size and all. So in this case, let's say I'm using OpenAI LLM. Okay, OpenAI LLM. So OpenAI LLM wise, I'll be using something called GPT 3.5 Turbo. So there is a model you will get from OpenAI called GPT 3.5 Turbo, and it has actually one specific input length. So that input length actually you need to see. If I open my data, if you see, this input length actually will be more than this 4000 token, because here if you see, I have loaded the entire documents. All the articles I have loaded. Okay, so there is a possibility this input size would be more than 4000 tokens. Okay, and if I'm converting all the corpus as my vector embeddings and I'm storing to the vector database, so it will create issue. Okay, so again during storing it will create issue, and whenever you will be giving this data to your LLM model, again it will be creating issue, and you will also get some memory error and all. Okay, so it's better to split our data as chunks. Okay, now what is chunks? So let me first of all tell you, chunks is nothing but, here I have already written, chunks is a size of the maximum number of the character that a chunks can contain. Okay, and there is another concept called chunks overlap. Okay, so chunks overlap is nothing but this is the number of character that should be overlap between two adjacent chunks. Okay, so let's say, so to explain this one, let's say I will take one text here. So let's say this is my entire corpus. Okay, now first of all I need to convert it to chunks. Okay, chunks means I'll be taking some of the chunk size. Okay, let's say if I am writing chunk size is equal to, let's say, 500, so it will take let's say I'll take a new color. So it will start from here, and it will go, and it will count like 500 character. Okay, it will count 500 character. So let's say this is this will end here. Okay, this will end here, and this should be one chunks. Okay, this should be one chunks. Okay, so again it will start from here. Again it will count, let's say, 500 word 500 character, and we call it as a token. Okay, so let's say this is the here it will end. So this should be another chunks. Okay, so let's say this is another chunks. This is another chunks. Now again, let's say it will start from here. It will start from here. Again it will count. Let's say it will end here. This is another chunks. Let's say again it will start from here, and let's say it will end here. Okay, I'm taking it randomly, just try to consider. So this is another chunks, and it will start from here, it will end here. Okay, now how many chunks we have got? So 1 chunks, 2 chunks, 3, 4, and 5. Okay, so here I got 5 chunks. Okay, 5 chunks. 5 chunks of the data. See, now if you count this input length, okay, now it should be less than, now my input size is less than 4097. Okay, so this is the idea of creating these chunks. Okay, instead of converting my entire corpus to the vector, first of all I need to create as a chunks. Okay, then I need to convert it to vector embedding, then I will be storing, and that embedding I will feed my LLM model. Okay. And there is another concept called chunks overlap. Okay. So what is chunks overlap? So if you set this chunks overlap, let's say I will set this chunks overlap, chunks underscore overlap. Let's say I have set as 20. So what it will do? So whenever, first of all, I will grab these are the chunks. Okay. Now let's create a new chunks again. So let's say whenever it will create a chunks, let's say it will start from here and chunk size is 500. So let's say it will end here. Now you have mentioned chunks overlap is equal to 20. Now what it will do, instead of starting from here, it will go back and it will count 20 character. Okay, it will count 20 character. Let's say this is my 20 character. Okay, now it will create the chunks from here. Now again it will count, and let's say your 500 character will end here. So this is my another chunks. Okay, so basically chunks overlap means like how much overlapping you are needed from your previous chunks. Okay, so that is called chunks overlap. So it helps you like to understand your context of the text. Okay, instead of using only chunk size, you can also use chunks overlap, so that it can also got to know like what was the previous context. Okay, whenever it will, let's say, see, I'm giving this chunks by chunks. Let's say this is my chunk 1, the chunk 2, and chunk 3. So okay, so instead of giving directly the chunks, if I'm also mentioning chunks overlap, so what will happen, your LLM model automatically will get to know, okay, so this is the context actually. So this sentence, okay, this sentence and this sentence, so after this sentence actually this sentence is coming. Okay, so that's why this chunk size, this chunks overlaps actually helps us. Okay, this chunks overlaps actually help us to understand the context of the entire story. Okay, so that's why we'll be using these two concepts called chunk size and chunks overlap. Okay, now I think this thing is clear. Now let me show you how to do it using code. So I'll come here. Now here, first of all, you need to import something called recursive character text splitter. Okay, so from LangChain dot text splitter, text underscore splitter, import recursive. So recursive character text splitter. Okay, so this is the class actually we'll be using to convert my entire corpus as a chunks. Okay, now I'll just call this class, and inside that you need to mention two parameter. I think I already explained. One is your chunk underscore size. Okay, chunk size. So let's define as 1000. Okay, I am considering 1000 character as my one chunk. Okay, you can give any number. So it's a hyperparameter tuning. You can set any number here, but I saw like people are starting with 1000 here. Okay, and there is another parameter you will give called chunk underscore overlap. So chunk overlap, I will give, let's say, 200. Okay, so again it's a hyperparameter tuning. Now guys, I have created this object. Now I will save this object. So I'll just create a variable called text splitter. Now guys, finally I will convert my entire corpus to my chunks. So I'll just call this object, and here you need to call split dot split underscore documents, and this is my entire documents. Okay, this is my raw documents, so I'll give it here, and I'll store in a document variable. Okay, or I can store it, I think, in a text variable. I think it should be fine. So let's make it as separate. Now let me execute. It's done. Now if I show you my text, guys, so you will be able to see it has converted to chunks, and how many chunks it has converted I will also show you. See guys, so if I just go up, so guys, see, this is my first chunks. Okay, and it is ending here. Then again it is another chunks. Okay, then it is ending here. Then again this is another chunks, and it is ending here. And from and if you see in each chunks actually you have 1000 character. Okay, 1000 character. And here if you see the chunks overlap, so if you read this text carefully, so you will see some of the sentence are coming, okay, in this new chunks as well. Okay, because we have set this chunks overlap as 200. Okay, so see, this is my entire chunks. Now if you want to see the length, like how many chunks it has created, so just print the length. So I'll just read as my text. So it has created 233 chunks, okay, altogether. Now it's fine. Now if you want to see any chunks, specific chunks, you just give the index. Let's say I want to see the number 1 chunks. This is the number 1 chunks, and I can also print number 2. Now we have successfully converted our like corpus to chunks. Now what I will do, I will create my DB object, okay, like vector DB object. So just write the comment here, creating DB object. So as I already told you, ChromaDB is nothing but it's a local database. So first of all, you need to create a local like DB here, okay, local DB. So you need to specify the name. So here I already prepared this code. So here you need to first of all create one persist directory, and the name can be anything. So here in this case I'm giving as DB, that means database, and you need to specify the embedding first of all, okay. Like I think you know why we need the embedding, because first of all I need to convert my text to embeddings, okay, that means vector. Then I will store this vector, okay, to my vector database, which is nothing but my ChromaDB. So in this case I'm using something called OpenAI embedding. I think you remember here we imported. So OpenAI embedding, so I'll just call it OpenAI embeddings. And by default, if you execute this code, so let me show you which embeddings model it is using. It has this model called text embedding ADA 002. This is the model. It has also another version, text ADA 001. Okay. Now we have successfully loaded our embedding model. Now what I need to do, I need to create my vector instance. Okay. I need to like create my vector database instance. So to create it, so this is the code for it. It's a simple code only. So first of all, I have created one variable called vector DB, and here I'm just calling my chroma. I think you remember we imported chroma from my LangChain. I'm just calling this chroma. So inside chroma, you have one function called from documents. Okay, from documents. Now here you just need to give the data, like you just need to give your text, like you just need to give your chunks, like which chunks actually you want to convert as a vector. So in this case, this is my chunks called text. As you can see, this is my text. I'll just copy the name, and here I'll just name it text, okay, and it will also take the embedding model. Okay, so this is the embedding model I want to use. So in this case, you can use any embedding model. You just need to import it here. Okay, so here I'm using OpenAI based embedding model, so that's why I have initialized it here. So here I'm giving the embedding model, and here you also need to give the persist directory, like where it will save after, let's say, converting to vectors, where it will save. So it will save inside this DB folder. Okay, so here I'm giving the directory. So these three parameter you just only need to give here. Okay, that's it. And if you're not giving any embedding model inside ChromaDB, it will automatically take OpenAI embedding model. Okay, I think they have already written here. If you see here embeddings, so they're automatically, I think, taking some embedding model using OpenAI API key and all. Okay, so they have already mentioned here, like it will automatically load, but it's better practice to mention. Okay, always better practice to mention here. That's it. Now if I execute it, so first of all, what you will do, I'll just remove this directory. Now see, it is converting everything to the vectors. Okay, all the text has been converted to vectors. Now I need to save it to my disk. Okay, now see, it has converted everything to the vector. Now I need to save it to the database. Okay, now this is the code for it. Just write vector db persist and vector db is equal to none. Now if I execute it, now you'll see it will create one db here, local db. Now if I refresh, see guys, db has been created. Now inside that, it has saved all the vector. Now see, it's a binary format. You can't see the vector here, so that is the issue with this local db. But whenever I will be showing you like Pinecone and Weaviate, you will able to see the vector, like how it has generated the vector. Okay, how it has generated the embedding, everything you can see in the cloud. Okay, you can like see all the list of the vector there. Okay, so that was the beauty of this cloud vector database, but again it's a local one. Okay, so that's why it's a binary representation here. So yes guys, we are successfully able to save our vector here. Okay, now let's say you want to load it. So how to load it? So this is the code for it. So here you just need to mention chroma. Okay, just call the chroma, and here you just need to mention the directory you have your data. So this is my database db. So here I'm giving the persist directory, which is nothing but db in this case. And here you also need to give the embedding. Okay, so this is the embedding I'm using. Now here I'm giving my persist directory. So in this case, it's db. Okay, now it will automatically load this vector and everything. Okay, from this db itself, because it's a binary representation. I already told you. Okay, and as well as I'm also giving my embedding model. Now let me load it. Now I think you remember I told you something called similarity search. Okay, now once we have loaded this vector to my vector database, now you can apply similarity search on top of it. Okay, we call it as retriever. Okay, retriever. So now let's show you the demo of the retriever. So I'll just comment it out, make retriever. Okay. So to retrieve any specific information with respect to the question you are asking, you need to set this parameter called vector as retriever. Okay, vector db. So this is my object, vector db as retriever, and this is my retriever object. Now let me execute. Now here I'll just call this retriever object, and here there is a parameter called get retrieve documents. Okay, that means I'm trying to tell my vector database whatever question I'm asking, try to give the similar kinds of you can say data, okay, with respect to the question I'm asking. So here I'll ask one question. Let's say here I have Microsoft articles as well. I think if you see here, I think Microsoft articles is also there. So I can ask one question, just like how much money did Microsoft raise? Okay, so let's say this is my question. Now by default, I'll store it in a docs. So by default, it will return for a relevant answer. Okay, for relevant answer. If I print it, see, it will return you for similarity answer. Okay, for most similar answer. Okay, like whatever vector are closed, I think I was explaining in the theory. So it is the most relevant and most similar answer. Okay, for most similar answer. So if I show you the length, so you can also set this parameter like how many relevant information you want. See, it is returning me 4. So let's say you only want, let's say, 2 relevant answer. Okay, so in this case you can set this parameter vector db as retrieve, search keyword as k2. Okay, k means like how many answer you want. Okay, so let's say I have given 2. Now if I execute it, okay, done. Now if you want to see like search type, so it's a similarity matrix. I think they're using similarity equation, they're using cosine similarity to calculate this answer. Okay, like the question you are asking, basically it will match with the vector, like what are the closest vector, okay, it will come, so it will return you. So they're considering this similarity cosine similarity matrix, I think there. Okay, so cosine similarity equation, and this parameter will give you like number of return actually it will provide. So it will only provide 2 answer. Okay, 2 answer. Now if I again execute this code, now see guys, now length is 2. Okay, it is only returning 2 answer. Okay, so using this parameter you can set like how many like answer or how many similar answer you want, okay, from your database. Okay, now see guys, it has written 2 or let's say 4 similar answer, but I want a specific output. Let's say the question I asked, okay, let's say if I print my document, so it's a different kinds of answer actually it will return. Okay, but it's not understandable actually. It's like it is giving like lots of answer and all. Okay, it's giving lots of text, but I want like a relevant answer. Like I just asked like how much money did Microsoft raise, so it should give me like that is the money Microsoft raised. Okay, so it should give me that kinds of answer, but it is returning this kinds of document. Okay, these kinds of chunks. So to get a specific output, okay, from your data, you can take a help from the LLM. So what you can do, let me show you the diagram. So let's say this is my vector db. Okay, now we have stored our vector embedding here. Vector embedding we have stored here. Okay, now you are giving any kinds of query. Let's say this is your query. So here in this case, let's say you asked like how much money Microsoft raise, right? So this is your question. So it is returning, let's say 4 or let's say 2 output documents. Okay, but this 4 or 2 output documents is not readable. Okay, I am not getting my specific answer. So what I can do, I can integrate LLM model. So let's say I will initialize my large language model here, which is nothing but GPT 3.5 turbo in this case. Okay, turbo. So I'll give this answer to my LLM model. Okay, I'll give this answer to my LLM model, and LLM model will analyze this answer it will also analyze this query. Okay, it will also analyze this query. With respect to that, it will give me the authentic output. Okay, the correct output, correct, meaningful output. Okay, that is the power of LLM. I think you know why it is powerful and all. Okay, because it has trained with huge amount of unstructured data, so it can perform all kinds of tasks. Okay, that's why we will be using LLM. Okay, to retrieve our specific answer with respect to the specific question I'm asking. Okay, so this is the idea. So now to do it, actually, first of all, I need to make one chain. Okay, so let me just comment it out. I think you know what is chain in LangChain. Okay, so I'm not going to explain because I think you already learned this chain in LangChain. Okay, why we use chain and all. So first of all, I need to import something called retrieval QA chain. Okay, so I'll just write from LangChain dot chains import retrieval. So whenever you are using vector database, okay, it is returning retrieval output, right? Like related output. So you need to use this retrieval QA. That means retrieval question answering chain. Okay, so it will help you to ask the question, okay, to the data actually you have stored in your DB. Okay, so that's why this chain is required. Retrieval question answering. So I'll import this chain. Now here, first of all, you need to make one chain. So I have already made one chain here. So this is the chain. So I'm just calling retrieval QA chain, and there is a function called from chain type. So here you need to specify the LLM model. So here in this case, I'm using OpenAI LLM model. Okay. So let me show you how it will give you the model. So if you just run it in a new cell, and here I'm giving this LLM model, and chain type is stuff. Okay. I think you already know what is chain type and all. And retriever. So you need to give the retriever object here. Okay. This is the retriever object. So basically whatever question you are asking, okay, whatever question you are asking, it will return you from this retriever, right? Because you have given this retriever here. Okay, so that's why you need to give this retriever object here, and you also need to give the return source documents. Okay, return source documents means it will return the source also. Like, see, we have lots of data here. If I show you, we have lots of article here. Okay, now which article it is referring to give the answer. Okay, it will also give you as a reference that article. Okay, so this is the idea of this. Now if I execute, now let's ask one question and print this response. Okay, so here I'm calling my QA chain, and this is the query. Same query I'm asking, how much did Microsoft raise the money. Okay, so this is the query I'm giving inside my chain, and this is the response of the LLM. Now if I print this, see guys, this is the query. Now it's telling around $10 billion. Okay, raised like this Microsoft, and this is the source document. Okay, but it's not readable. So what you can do, actually, you can write one function here, process LLM output or process LLM response. So this is the function you can write. So whatever response it will give, it will process only, like it will give it the result, source, and the answer. Okay, now if I execute, now if I call this function here, now I'll just remove this response here. Okay, now I think it should give me the yeah. So now you can see this is the clear output. Now around $10 billion, and these are the source. Actually, it has referred this to file as a source. Now see guys, we are able to successfully store our vector to the vector database, and we are also able to make the query on top of that. And we also saw that, like, how we can found the similar kinds of you can say output, okay, using this retrieve. Okay, using this retrieve option. Okay, so you can ask any different question also. So let's say I will ask another question here. So what is the news about Pando? So there is again another Pando articles you will see inside the data. Now again, I'm giving inside my chain, and it is giving the response, and I'm just processing the response. Now see, Pando is a startup that has raised $30 billion in a Series B round, and bringing its total raised. Okay, so this is the complete answer, and this is the source it is giving. Okay, I think I don't need to print this. Yeah, so this is the source. So yes guys, that's how actually you can do it. And one thing I also want to show you, like how to, let's say you want to delete this database, so how to do it. So deleting DB. So it's like very easy. First of all, you can make a zip file, okay, of your existing DB, so that later on if you want to retrieve it, you can retrieve it. Okay, so first of all, I'm making it a zip file, then I'll be deleting it. So first of all, I'll make a zip file. Now see guys, if I refresh, so first of all, it will make a zip file of this DB. Okay, now I'll be deleting. So this is the deleting code. So it will clean up everything. Now if I refresh, now see database has been deleted. Okay, now let's say you want to get your previous DB. Okay, like you had, let's say, some specific or let's say important vector there, you want to get back. So what you can do, you can unzip that zip file. Okay, so this is the zip file, you can unzip. Now again your database will come. Now what you need to do, you need to restart the runtime. Okay, so just click here and there is option called restart the runtime. If you restart the runtime, again you can able to use your DB same wise. Okay, like we already imported our DB right here. So here, that's how we can load your DB again. Okay, so guys, now we'll start with the Langsmith demo. So this is another ecosystem from the LangChain. So they have created this amazing LLMOps platform. This is called actually Langsmith. So here I'm going to show you how we can build, monitor and trace our LLM powered application, okay, with the help of this Langsmith platform. So let's see the practical demo of this Langsmith. So what is Langsmith? So Langsmith is a it's an ecosystem. Okay, it's an ecosystem of LangChain. So LangChain has different ecosystem. I already told you. So LangChain has different ecosystem, like LangServe is there, LangGraph is there. So Langsmith is one of them. Okay, Langsmith. And this is a LLMOps platform. Okay, LLMOps platform they have developed. So with the help of this Langsmith, what we can perform, guys, we can do the monitoring. Okay, we can do the debug. We can do the like tracing. Okay, even you can also perform the evaluation. Okay, evaluation of your application. So this is a little bit advanced one. We'll also try to discuss, okay, how we can perform the evaluation of our application. So in this actually session, I'll be showing you how we can monitor, debug and tracing our application. Let's say if you are creating any kinds of application, at the end you also need to integrate these kinds of LLMOps tools so that you can get to know, okay, so what is going on inside your application. You can get the entire experiment there. Okay, let's say many people will ask like how we can trace our cost, like how much it is charging, okay, based on the request I'm sending to the model. So each and everything you can monitor. Okay, so these kinds of functionality Langsmith usually provides. Okay, so LangChain has created one amazing platform called Langsmith. So with the help of that, you can monitor, debug, trace and evaluation your LLM powered application. Okay, so for this we'll be using this particular Langsmith platform, and this is called LLMOps platform. Okay, LangChain has created. Fine. So now what I will show you guys, I think practical demo would be better, because what I believe in practical, unless and until I'm not showing you the practical, things would be more difficult. So first of all, we'll see the practical demo. So I already prepared the code and everything. Okay, I'll just execute and I will show you, okay, how we can configure with the Langsmith and all, and how we can monitor, debug and trace our application. Okay, so for this we'll be first of all opening the LangChain website. Okay, so let me just open the LangChain website. So I'll open the LangChain website. So the first thing, you have to create one account in the LangChain website, guys. Okay, so everyone, if you don't have the account, first of all try to create one account in the LangChain website. So for me, I already have the account. If you don't have the account, guys, just try to sign up with your email address and you will be getting one account. So for me, I already have the account. I'll just try to do the sign up here. See, for me, it will automatically log in. See, okay, so initially we'll see these kinds of interface, but for me, see, I already created actually one project here. I was tracking one project. That's why you can see this particular project name. But if you're opening for the first time, you'll see that it would be completely empty dashboard. Okay, now the first thing what you have to do, guys, so you can see this is the Langsmith platform. Now you can also open up the documentation. I think so they have also given the documentation link somewhere. So let me open the documentation. See, this is the documentation. So this is the Langsmith documentation. So here they have already written, with the help of Langsmith, it's a platform for building production grade LLM application. It allows you to closely monitor, evaluate your application so you can ship quickly with the confidence. Use of LangChain is not necessary. Langsmith works on its own. That means you don't need to configure so many things here. Only you just need to set some environment variable and all, and everything will be tracing automatically. Okay. Even they have also given some example like how we can install it. Okay, so if you're using LangChain, so you don't need to install Langsmith separately. Okay, it will be working fine. Now you have to create the API key of the Langsmith. Then after that you have to set it as an environment variable. And if you're using any other operating system, you can also export it. Okay, and they have also given some of the demo. But again, I told you LangChain documentation is a little bit complex for the beginner. So first of all, see my code example. Okay, whatever application I'm showing you, first of all try to see, then try to go through the documentation. Okay, even they have already given the tutorial related evaluation, prompt engineering. Okay, even they have also integrated LangGraph like cloud. If you want to, let's say, integrate the Lang server and all, you can also do it. Okay, but as of now it's not required. We'll be using the Langsmith for the monitoring our application. Okay, this is our main objective. So for these guys, first of all, let's create one API key. And how to create the API key? So for this, open up your dashboard, and left hand side you will see there is a setting option. Okay, now click on the setting option. Now here you can create the API key. Okay, see there is an option, create an API key. So if you don't have the API key, guys, just try to create an API key. For me, I already created. Okay, so you can see for me I already created. So let me, what I can do, I can delete this API key. The API key actually I created, I can delete it. Now I'll be creating a new one. So create API key, you can give the name. Let's say I'll give my key and create it as a personal access token and create the API key. And make sure you copy it and paste it inside your env file. Okay, now see this is my env file, and here you have to write this particular key name, LangChain API key. Okay, inside that you have to paste this particular key. So let me paste my key. Okay, don't use my key, guys. I'll try to remove it after this session. Okay, just try to create your own API key and try to mention here. Then you have to give another key, which is nothing but LangChain project. That means the experiment actually it will be tracking, right? So it will save as a project. So you have to give the project name. So by default, whatever name actually you'll be providing here, it will use that particular name. So here I will give, let's say, my LLM app. The previous I already created one app called my LLM app. Now what I can do, I can, let's say, change it. So I'll give test. Okay, test app. So I've given this name. You can give any name. Okay, it's up to you. Now let me save, and it's done. Now let's create out. Now what you can do, you can create a Jupyter notebook. So for me, I already created a Jupyter notebook, guys. You can see, and I have already written the code example. Okay, how we can use this particular Langsmith. So again, these are the code snippet. I think you already familiar with. I already explained everything inside LangChain. Okay, so here I'm importing operating system library, then chat OpenAI because we'll be using the chat completion model. Then chat prompt template, HTR, output parser. Okay, then load env. So I think you already familiar with these are the packages. Okay, now let me import them. Now the next thing, you have to load the like secret credential. Okay, you have to load the OpenAI API key. You have to load the LangChain API key. Okay, and you can, in case you can also use any other model. You can use Grok model. Okay, any other model you can use. So here I'm using the OpenAI model. And so if you're using Langsmith, one things you have to assign, which is nothing but LangChain tracing v2 is equal to true. So if you go to the documentation of LangServe, let me show you. So if I go to the documentation, so they're telling, see here. So this one, LangChain tracking v2 is equal to true. You have to provide this particular statement. Okay, if you're not providing, your execution won't be logged inside Langsmith. Okay, that means it won't be tracing. But if you're giving it as true, it will automatically start tracing your experiment. Okay, so this is super important, guys, and this is what you have to remember in Langsmith. Okay, nothing else. Everything will take care by LangChain only. Got it? Now see here I have mentioned LangChain underscore trace tracking underscore v2 is equal to true. And why v2? Because we are using second generation of LangChain. Okay, second generation of LangChain. That's why we have given the v2 version 2. Got it? Now let me load the environment. Now here I'm creating the chat prompt template. I think you know what is chat prompt template. If I want to give some prompt to my LLM, first of all I have to create the prompt template. So here I'm creating my prompt template, and here I'm using the chat completion model. That's why I have to give the system prompt as well as the user prompt. So this is my system prompt. You are a helpful assistant. Please respond to the user request only based on the given context. Now this is the user. So user, in case actually what user will pass the question, and they can also pass the context. Okay, so context wise they can also pass. So this is my entire prompt template I have created. Now I'm initializing the model. I'm using the GPT 3.5 turbo model and as well as the output parser. Okay, now this is a basic simple chain I'm creating with the help of LCL, that means LangChain expression language. And I already told you this kinds of ecosystem supports latest LangChain, okay, the second generation of LangChain. Okay, if you're using the legacy LangChain, in case actually it won't be working. Okay, that's why I already told you have to learn the second generation of LangChain. Now this is my simple chain prompt model and output parser. So first of all, prompt will be created, then it will pass to the model will give me the response, and it will pass to the output parser, and output parser will return the string output. Okay, this is the idea. Now let me create the chain. Now here is my question. So here I'm giving one question: can you summarize this story? And story wise, I've given this particular story. You can see inside the context. So I have copy pasted this story from Google. So if you can search like English story, we'll be getting different story. So here you can paste anything, or if you have any other documents, you can also pass it here. Okay, now this is my question: can you summarize this story or not? Okay, so this is my question. Now here I'm passing it to my actually chain. So chain.invoke question is equal to question I'm giving, and the context is equal to context I'm giving. Okay, now see if I execute it. So here I will get the summary. Okay, this is the entire summary actually I got. Now if you go to the Langsmith, okay, if you go to the Langsmith, and if I go to the, let's say, tracking project, okay, in this section, now you'll see that the latest actually track would be visible. So this is my previous one. Okay, this is my previous one. You can see the timing. Okay, in this timing, at this time actually I was experimenting this application. Now this is the new one, test app. The name actually I have given inside my environment variable. It is utilizing the same name. Okay, now you can see the created date and everything. It would be visible. Now you can also see some of the like messages like error rate. So are you getting any error or not? Then latency. Okay, like how much actually time it took to execute the application. Okay, so different actually log you can see. Now total token, total cost. See, now you can track you can monitor your cost, like how much it is charging. So here we are using OpenAI model. So the request actually I send. Okay, so based on the request, what is the charge? So see, it is charging $0.0000181. Okay, and this is the date. Now I can also open it up and I can see detailedly, okay, what it's trying to say. Now see, entire log you can see here. Okay, like the run count, like only one time I executed, the total cost, okay, then token and latency, okay, everything you can see here. Okay, everything, all the metadata you can visualize here, okay, in this Langsmith platform. So this is one amazing platform they have created. Now if you want to see in detail, so what you can do, simply you can click here. See, it is logging as a runnable sequence. Okay, now I think you can answer me why runnable sequence, because I already told you whenever we create a change, that means we are executing runnable, yes or no, sequence of runnable. Okay, that's why it is logging as a runnable sequence. Okay, now inside runnable sequence, what we have, guys, we have different kinds of runnable. Okay, like we have our model, we have our prompt. Okay, then we have the output parser, and you can see this is the input. Okay, this is my input and this is the context. Based on that, it has given me this particular answer, output. Okay, if you want to see as a JSON, you can also see. If you want to say as a YAML file, you can also see. Okay, now status is success, that means there was no error. Now you can see the feedback. So if any feedback is required, it will automatically give you the feedback. It will also show you the metadata, like what is the version and everything you are using. Okay, so everything it will show you. Everything it will show you. That means each and everything you can monitor here of your application. Okay, so this is one of the amazing product actually LangChain team has developed. Even personally, I prefer a lot. So it will give you the entire clear-cut idea about your application, like the cost, everything. Okay, everything. Even you can also evaluate your application. Okay, so I think future will also show that how we can evaluate our application. Now see, apart from that, I think some more functionality are there. So let me open it up. So what I can do, I can show you the monitor section. So inside monitor section, it will show you the graph based on the, let's say, hour and day basis. So I just executed my project as of now. That's why there is nothing. But after 1 year or after 9 days, okay, or 1 day, you will see it will show you the different graph, like volume, latency, tokens, cost, okay, streaming, everything it will show you. Now setup wise, if you want to set up it, so they are also giving the tutorial, but I don't need it. I already set up this project. Now I'll go to the run section. I'll click on the all runs. And inside all runs, you'll see whatever runnables you had, everything it will show you. Let's say So I had different runnables get, remember. So prompt was there, model was there, output parser was there. Okay, so you can see output parser, our model, okay, then our prompt. Okay, now this is the sequence runnable, that means the entire runnable. Now you can also open them individually. Let's say I want to see the output parser only. In case, I can open it up and I can see, okay, what output parser is doing. It is giving me the string as in output. Okay, that's how we can see the model size, model as well. So what is the model you are using? Okay, the model input, model output, everything, it is visible. Okay, and the token, the cost, okay, everything it will show you. So with the help of this Langsmith, we can do some more advanced stuff. Maybe in future I will also show you, but as of now, that's how you can monitor your entire application. Okay, in MLOps, if you have used something called MLflow, anyone, so I think you can relate, okay, MLflow with this Langsmith, because in MLflow also we can track our experiment. Okay, so inside this Langsmith also we can track our experiment. Let's say you are executing for the next time, second time. So what I can do, let's say I can change this question. So here I can write, can you summarize this story? Instead of that, I can just write, what is this story all about? Okay, all about. Now if I again execute, okay, now see, if I go to the Langsmith again, and if I just click here, test tab, now see the second execution. Okay, the second log just 1.92 seconds ago. Okay, sorry, it's a latency, but you can see the time as well. So I can show you the time. I think time, you see, you can see the time. Okay, got it. So you can see this is the next experiment. Now if I open it up, so you can see this is the question, and this was my actually context, and this is my response. Okay, so that's how we can track a different experiment. Okay, with different actually, let's say, runnables, different actually input output. Okay, everything you can trace. So this is why important. I think whenever you are creating production grade application, so you should also integrate this kinds of functionality. And to integrate it, so you only just need to add this particular syntax. Okay, that's it, and everything would be automated in the platform itself. I hope now you are clear with this Langsmith. Okay, how Langsmith works. So guys, now we'll see the LangServe demo, like how LangServe works, and with the help of LangServe actually what we can perform. So this is one amazing ecosystem actually LangChain has developed. So let's see the practical demo of LangServe. I think then it would be clear. So first of all, you have to understand what is LangServe. Okay, what is LangServe exactly and why it is required. See, LangServe is nothing but it's a LangChain. It's a LangChain ecosystem. Okay, ecosystem. You can also call it as like LLMOps. Okay, LLMOps framework or tool. Okay, so with the help of this, what we perform, guys, we build simple LLM apps. Okay, apps. You can also call it as web app. You can also call it as API. Okay, application programming interface, so that user can test my application. Let's say you have created one application. So let's say you have used one large language model, LLM. With that, what you have done, you have created one RAG application. I think you know what is RAG application, right? You created a RAG application. Now this application you have created in your local machine. That means it is running on your local machine. Okay, only you can access this particular, let's say, like application. You can test this application. But let's say you want to share with some specific person. Let's say you want to share with your manager, or let's say your stakeholder, or let's say your client. That time, let's say your client want to see how this particular application is working, whether everything is fine or not. He just want to test it. Like he's telling, I want to test that application. If everything is working fine, if I'm liking this particular, let's say, project, then we'll be pushing this project to the production. Okay, so before pushing it to the production, first of all, you have to test you have to test, and for testing you have to share this application with some of the person. So how to do it? Okay, for this you will be using something called this LangChain. Okay, LangChain. So when we didn't have the LangChain, guys, what we used to use, I think you remember, we used to use a Flask to create the API or web interface. We used to use something called Streamlit. Okay, then we used to use something called FastAPI. Okay, FastAPI. So that's how actually we are having different kinds of web framework. Okay, with the help of that you can easily create a API, okay, or web app. Okay, easily you can create a web app or API, and this web app you can simply deploy and you can share with your, let's say, client or stakeholder, or let's say to your manager, and they can test your application. Okay, it's working fine or not. But if I'm using these are the tools, then I should have knowledge on these are the tools. Let's say if you want to use Flask, so definitely you should have knowledge on the Flask. That means you have to learn the basics of Flask, like how to create the API, how to create the web app and all, right? And again, if you're using Flask, you have to also learn how to write the HTML code. Okay, HTML code, how to write the CSS code. With the help of that, you'll be creating the template. If I'm talking about Streamlit, again, it's a Python package. Here you don't need the HTML and CSS code, but again, you have to learn some basic syntax. Okay, if I'm talking about FastAPI, FastAPI is the production ready actually web framework, or let's say API framework. So with the help of that, you can create a production grade API, production grade actually application. But again, you have to learn the FastAPI, because if you see the FastAPI, okay, if I open this FastAPI documentation, you'll see that it's a like huge package actually. It's a production grade package actually developed, and inside that we are having so many concepts. But again, see, I don't recommend you have to learn all of them, because you as a generative AI developer, your task is to create the application. Okay, your task is to create use the model. You have to create the application. And when it comes to create the web interface, that means user interface, let's say if I'm talking about ChatGPT, it's a full stack development, yes or no? Because they're using let's say React, they're using Node.js. Okay, with the help of that, they are creating the beautiful web interface. They are creating interactive web interface. But as a generative AI developer, this is not my task. There would be other team, they will be creating this particular web application. But in the backend, okay, in the backend, the mechanism actually, let's say it is using, that means the core generative AI concept it is using, this is your responsibility to create. Okay, but initially, whenever you are creating your application, now you have to create some basics API, so that at least you can test this particular application, or your manager or your client, let's say, test this particular application. Okay, for this we can use these are the framework like Flask, Streamlit, FastAPI. But again, I should have knowledge on this one. But let's say you don't have the knowledge, then that time what you have to do, again you have to take the help from the web developer, or let's say a front-end developer, yes or no? So that's why LangChain, what they did is they introduced something called LangChain. LangChain, they introduced LangChain, and this is an ecosystem. Okay, LangChain. And what is LangChain? You can go to the simply LangChain documentation. LangChain docs. You can see the LangChain documentation. So LangChain helps developer deploy LangChain runables and chains as a REST API. That means with the help of that, you can create a API, or you can create an application, and this application you can deploy. Okay, you can easily deploy, okay, as a REST API. I think you know what is REST API. That means you will be getting one API interface. With the help of that, you can send the request. Okay, not only that, you will be also getting some web interface, because they have integrated web interface as also. Let's say you will be getting the input box and all. That is also possible here. So you can see this, the entire documentation, like how we can use this and all. So in which port and which route you have to go, everything they have given. Okay, but again, I told you LangChain documentation is a little bit hard to understand. So what I will do, I will first of all show you like how we can use this particular, let's say, LangChain in our project. Then you can go through the documentation. Each and everything would be clear, because you can see they have given so many examples. Okay, and I know that initially it would be a little bit hard for you to understand, okay, what they are writing and all. But first of all, let me show you my implementation. Okay, then you can go through the entire documentation, and I will recommend, guys, please try to go through the documentation. Unless and until you are not going through the documentation, so you won't be able to get the in-depth idea. Okay, I'll show the demo how we can use this LangChain. But if you want to learn more about the LangChain, you can go to the documentation. Okay, that should be my suggestion, all of you. So now let me show you the demo how we can actually use this LangChain in our implementation. and how we can create the REST API. Okay, so I'll show you. And one more thing I want to tell you, see this LangServe they have created. In the backend, they're using FastAPI only. Okay, they're using FastAPI only. So it is the high level of the FastAPI. Okay, if you go through the FastAPI documentation, you'll see that to use the FastAPI, you have to write so many code, right? So many configuration you have to do. But if you're using LangServe, you don't need to do it. Based on the FastAPI, actually they created this LangServe. Okay, LangServe, this tool. Now let me show you how we can use this one. So for this, I'm going to open up my VS Code. So here I'm going to see if you're using actually LangServe, instead of running from your Jupyter notebook, you can create a Python file. That would be better, because see, Jupyter notebook we won't be using whenever we are developing the application. Okay, so whenever we are experimenting the things, that time we'll be using, but whenever we are creating any application, that time we'll be using the Python file. So let's me create a Python file here. So I'll name it as 10. I can name it as, let's say, LangServe. Okay, LangServe underscore demo.py. So the first thing, you have to install the LangServe. Okay, in the requirements, you have to mention the LangServe. So let me mention it. So here is the LangServe package, because LangChain actually created this framework separately. So you have to install it separately. Okay, so you can see I'm installing this LangServe 0.2.2. Okay, you can also use any other version, but I'm using this version because this is the stable version I'm using. Now I have to set up it. So to set up it, guys, what you have to do, just open up your terminal in your directory. So let's say this is my directory. I'll open up my terminal, and I think you remember we created a virtual environment. So inside this readme, I shared the command. So this is my environment I created. You can activate, and simply you can run this requirement.txt command. Okay, so it will install this LangServe in your actually environment. So for me, I already installed, so that's why I'm not going to install it again. Okay, now here simply I'm going to create a simple app. Okay, simple actually translator app. So let me just write here. I'm going to implement what? Simple translator app. Okay, translator app. Okay, so what this app will do, it will take actually two input. One is the, let's say, language you want to translate. Okay, other one is the text you want to translate. Okay, so these two input this application will be taking. So let me just come here. So for this, I think you know how to actually initialize the large language model and all, because I already taught you in my previous session. So first of all, let me import all of the necessary package I need. So I think you are already familiar with these are the package, guys. Okay, so chat prompt template, str output parser, chat OpenAI. Okay, then python.env, because I have to load my OpenAI API key. So let me select my environment. So this is my environment, LLM app. Okay, this one. Apart from that, I also need something called operating system. Then I'm going to load my OpenAI API key. So let me load. So this will load your OpenAI API key. Okay, then I'm going to initialize the OpenAI model. You can also use Grok API. If you don't have the OpenAI account, that time you can use Grok API. So this is my LLM wrapper. Then I'm going to also create the output parser, and I think you know what is output parser. Okay, we can reformat the output. Then I'm going to create a prompt. So first of all, I'm going to create a system prompt template. So this is the system prompt template, and here I'm giving the system prompt, translate the following into this specific language. The language actually user will give. Let's say user want to translate in the Hindi, Bengali, Spanish. Okay, that time user will give the input and it will come here. It will create the complete prompt. Okay, now I have to create the prompt template. I think you know how to create the prompt template. So this is the syntax. So chat prompt template from message. Inside that, give the system prompt, and whatever user input will provide, okay, will pass in the text variable. This is the idea. Now we'll be creating the chain. So here we are using LangChain expression language to create the chain. You can see prompt template, then LLM, then output parser, sequence of execution. And to create the actually REST API with the help of LangServe, you have to import first of all FastAPI. Okay, you have to first of all import FastAPI, and you have to import another library from the LangChain called add routes. Okay, these two things you have to import, guys. Try to remember these two things you have to remember. And inside FastAPI object, you have to mention these are the syntax. See, so we have already imported FastAPI. Inside that, I'm passing the title. Title is simple translator. You can give anything. You can also give any kinds of version. I have given 1.0, and this is the description I have given: a simple API server using LangChain's runnable interfaces. Okay, now we have imported another library called add routes. Okay, inside that we have to pass this object. See, so app routes, I'm passing my app, then whatever chain actually I have created, and the path. Okay, path should be the chain /chain. Why /chain? I'll tell you. Whenever I'll execute the application, you'll see that I have to go to the /chain. Okay, /chain actually route, and this route actually it will execute. And I also need to initialize the application. For this, I need this package actually called Euron, and with the help of Euron, we'll be starting the application. See, that's it. That's it. So Euron run, give the app, give the localhost port number, anything you can give. I've given 8000 port number. This is, this is what you have to write. Okay. Now, see, if you go to the FastAPI documentation, you have to write so many code. But here, we haven't written so many code. We are only using LangChain. Okay. With the help of that, easily we are creating the REST API. Now, how to execute, guys? So for this, just open up your terminal. Okay. Open up your terminal. Just a minute. And you have to execute this file. Okay, so you have to execute this demo file you have created. So let me execute Python 10 langchain demo.py. Now see, if I execute, so it will see automatically it will install initialize LangChain. You can see LangChain would be there. Now this application is running on your localhost port number 8000. Now see, if I open this localhost port number 8000, you will see there is nothing. Okay, so for this you have to go to chain route. So chain, okay, chain/playground. This is the route, guys. Chain/playground. Okay, if you go to this route, you will see the application interface, and this is the REST API, guys, we have created. Now let me zoom. See, this is the interface, and by default, LangChain has created this interface. Okay, so you don't need to write HTML and CSS code for this. Now you can see we are having two input. One is the language, another is the text. The input actually you have written here, I think, remember. So I need two input. One is the text, another is the language. Okay, these two input automatically it is coming. Okay, now here you can test this application. Let's say I will give language. Let's say I want to translate in Hindi. Okay, and text, let's say I will give my name is Bappi. Okay, or anything you can give. Now simply you can start the translation. Now see, mera naam Bappi hai. Okay, now again you can give the prompt. Another prompt you can give. Let's say here I can give tell me about Python. See, so amazing response actually we are getting. See, okay, amazing response we are getting. Now if you want to, let's say, hit this particular REST API, so for this you can also execute this code. So here Python SDK code I'll copy, and I'm going to create another file called test.py. Okay, inside that I'm going to paste it. See, this is the code. Okay, this is the code. Now here simply you have to give the message. Let's say you want to perform the invoke operation. So here you can write this thing. So inside this invoke you can give the input text. Let's say this is my input text. Language is Spanish, and text is equal to generative AI is the bigger opportunity than internet. So this thing I want to send the request. So I can execute. First of all, I'll be taking another terminal here. Just a minute. So my previous terminal is running, and now I'm taking a new terminal here. So first of all, let me activate my environment. Okay, then I'll execute this test.py. So Python test.py. Okay, I'm not getting any output because okay, chain.invoke we are doing. So we have to first of all save inside a variable, and this variable we have to print. Now let me try. See the response we are getting. Now let's say this is your server. Okay, this is your development server. That means the demo server, POC server. You are running your application, and your manager, or let's say your client, are testing your application. Okay, how it is working. Either they can test with the help of web interface. Okay, either they can test with the help of web interface. Either they can use this particular code. Okay, the syntax I shared with you, Python SDK. Okay, with the help of API request also they can test your application. So this is called actually LangChain. Okay, so during development environment you'll be using this particular tool. Okay, just to test your application whether it's working fine or not. Now let's say everything is working fine, it is ready for the production. That time your front-end developer will come and they will create one beautiful interface and they will connect your application, and this application would be available in the production server like the ChatGPT. Okay, I hope it is clear. So this is the simple demo of the LangChain. Now simply you can go to the documentation. Okay, the entire LangChain documentation. Now you'll be able to understand, okay, whatever things I showed you. So simply go to the documentation, guys, and please try to practice at least, okay, whatever they have given. And if you face any issue, you can let me know in the comment. I'll happy to help you.
Hi guys, in this video I'll be discussing about Hugging Face inference endpoints. So this is one platform from the Hugging Face. If you search like Hugging Face co/inference endpoints /dedicated, you will be able to get this particular platform. So here what you can do, you can turn your AI model into APIs. That means here you can host any kinds of like large language model, okay, as an API. And this is the fully managed actually, let's say platform by the Hugging Face. So here you don't need to worry about the load balancing, you don't need to worry about the auto scaling. Okay, everything they'll be doing. So only you just need to do some few clicks, and with the few clicks you will be able to deploy your model. So with the few clicks you will be able to deploy your model, okay, over the Hugging Face inference endpoints, okay, as an inference API you will be getting. So here you can see deploy any AI model on dedicated fully managed CPU, GPUs and AWS inference here to keep your cost low with auto scaling and scale to 0. Okay, because what happens if you are deploying your model over any other platform, let's say with the help of deep learning container you are deploying over the SageMaker platform. So if you see the SageMaker cost is like very high there, you also need to do like manual auto scaling, load balancing, everything you have to do manually. And to manage the LLM actually it's like very difficult there. But here actually it's not that much of difficult because everything is managed by the Hugging Face platform. So they have given one beautiful documentation, so you can refer the documentation, guys. So see, they have given everything. They have also given the like pricing and all, like what are the price they are taking, okay, per hour, everything they have given. And this is the like architecture. So let's say this is the user, and first of all he needs to create one user endpoint, okay, like model endpoint. Then he can take the model from the Hugging Face repository. Either he can take the model from his repository, okay, let's say he has trained one custom model, that custom model also he can take. Then he can initialize the compute like the cloud platform. Then he can deploy the model as an endpoint. Then this particular endpoint can access different kinds of user. Okay, this is the entire like architecture. So now let me show you how you can deploy your model over the inference API. So here you can see, guys, production inference made easy. So here you can deploy model with just a few clicks, keep your production cost down, and enterprise level security you'll be getting. So here first of all you have to select the model. Okay, here you'll be getting these kinds of option. You have to select the model. First of all select the repository, then select the endpoint of your model. So you can see select the model you want to deploy. You can deploy custom models or any 60,000 plus transformer diffusion or sentence transformer models are available on the hub for NLP, computer vision or speech task. That means you can either select your custom model, either you can select 60,000 plus model, okay, from the Hugging Face hub. Okay, any kinds of model you can select and you can deploy as an endpoint. Got it? So you can see guys, after that you have to choose the provider, whether you want to host over the AWS, whether you want to host over the, let's say, Azure, whether you want to host over the GCP cloud. Then you can also select the region. Okay, you can see pick your cloud and select the region to choose your data in compliance with your requirements. Okay, now once it is done, you can select the security level. So here you have three kinds of security: protected, public, and private. So you can see protected endpoints are accessible from the internet and requires valid authentication. That means it needs the valid authentication, then you'll be able to access the endpoints. Then we have public endpoints. So public endpoints are accessible from the internet and do not require any authentication. That means you can easily access those are the endpoint. Okay, then private endpoints are only available through an intra-region secured AWS or Azure private link direct connections to VPC and are not accessible from the internet. Okay, now once you have selected the security level, then you can create the endpoints. So once it is created, then you can manage your endpoints. Okay, so you'll be getting one endpoints URL like that. So if you hit that particular endpoints URL, you'll be able to access the model and you'll be able to get the response. Got it? So I will also discuss how we can create our own API, okay, with the help of FastAPI. So with the help of FastAPI also you can create the API, okay, API. So there also you can hit the route and you can get the response from your large language model. So I will also show you how we can use FastAPI for the LLM inference. So this is like the hosted platform guys over the Hugging Face. So there you will be getting different machines, okay, with the help of CPU, GPU, everything you will be getting. Now you can see this is the entire documentation, and they have also given their official tutorial. You can also refer that. Now guys, this is not a free actually. For this you have to pay. So let me show you. So if I, let's say, want to deploy any kinds of model, I'll click on the button. Now here you can see, here you have different model. You can also select the model from the Hugging Face. Okay, now let's say I want to deploy this particular model. So here per hour it will charge you $0.8, and it is using GPU 1x NVIDIA L4 GPU. Okay, and this is the model. Now if I click here, you'll be able to see that it is coming different options like endpoint name. Then you can also select more options like common revision task. Okay, you can everything you can provide everything. Now you can also give the hardware configuration, like what is the GPU want. Based on the price you can select your GPU. Okay, now you can also select the security level, then auto scaling if you want to do. So everything is available. Okay, so once it is done, you have to add your card. You can see there is an option called add your card. So first of all, you have to create one Hugging Face account. Once you have created the Hugging Face account, then you will be able to add your payment card. So once it is done, you can click here, create endpoints. Then you will be able to see the endpoint URL, and with respect to the URL, you will be able to access the model, and everything is mentioned in the documentation, guys. Okay, so they have given one beautiful documentation that you can check it out. So again, guys, it's a paid one. So as per your requirement, you can select the model and you can use this particular Hugging Face Inference Hub. So I think, guys, you got to know what is Hugging Face Inference Hub, because this is another LLMOps platform I can talk about, because here you can host your large language model if you want. So with that, guys, thank you so much for watching this video, and I will see you next time. Hi everyone. In this video, I will show you how we can use FastAPI for LLM inference. So what is FastAPI? FastAPI is nothing but it's a modern, fast, high performance web framework for building APIs, okay, with Python. So you can use FastAPI for the web app implementation also. Okay, apart from FastAPI, there are some more frameworks are available, but FastAPI is like very you can say fast, and it is production ready. Okay, and it is most used. Okay, if you see, I think I showed you one demo of LangChain. They're using FastAPI in the backend. Okay, I think you got to know. With the help of that, they're serving the model. Now we'll try to learn how we can create our own, let's say, route, how we can create our own API if I want to access the large language model, right? So now I'm going to show you how we can create our own API and how we can, let's say, inference with respect to the large language model. Now guys, in this video I'm going to show you how we can create our own, let's say, API, and how we can let's say do the inference operation with the help of large language model. So for this, what you can do, guys, you can refer the documentation. So they have already given the installation guidelines, they have already given the snippet code. Okay, you can refer it. So I'll open up my local folder, and here what I will do, I will open up my Visual Code Studio. First of all, let me open up my terminal. So you should have, guys, Anaconda, okay, installed in your system. Anaconda you should have. If you don't have the Anaconda, just try to download from here. It's Anaconda download. So just try to download. If you're using Windows, Mac, okay, Linux, with respect to that, you can download the Anaconda. The way you install any kinds of software, you just try to install the Anaconda. Okay. In the second tool, you need something called Visual Code Studio. So here I have my Visual Code Studio. If you don't have, just try to download it from Google. So just write VS Code download. So this is the first website. From here you can download the Visual Code Studio as per your operating system. Got it? So I already have like all the tools in my system. I'm also expecting you already have Now what I will do, guys, the first thing you have to create one environment. Okay, you have to create one conda environment here. So for me, I already have the environment. Let me show you. So conda env list. Okay, so here previously I already created one environment called LLM app, but if you don't have the environment for this, you can write this command. So conda create, okay, hyphen n, then you can give the name of the environment, let's say LLM app. Then you can also specify the Python version. Python is equal to 3.11. Okay, then hyphen y. So this is the command, guys, you have to execute. Once you run the command, it will create the environment for you. Now for me, I already have it, so I'll just try to activate. So conda activate LLM app. Okay, and if you see the version of the Python, it's 3.11. So now let me do the exit operation. Okay, fine. Now what I will do, guys, I'll just try to create the folder structure. So the first thing, you need the requirement.txt file. So let's create a file called requirement, okay, .txt. Then the second file you need called schema.py. Schema, I think. Then third file you need called model loader.py, and the final file you need called main.py. So these are the files I need, okay, for this particular demo. Now, guys, what I will do, first of all, I will just mention all the requirements I need here for this particular demo. So these are the requirement I need. I'm installing the FastAPI, UVCon to run the FastAPI, that's a file. Then transformer, because I'm going to use the large language model from the Hugging Face. For this, I need the transformer. And dependency wise, you need the PyTorch, then PyDentic for the schema management. Okay. Now let me install all the packages. So to install the package, you have to run this command. So pip install -r requirements. Okay, requirement.txt. So it will install everything. For me, it is already installed because previously I already installed. For you, it will take some time. Okay, so once it is done, now start writing the code. So first of all, I'll write the schema.py. So here we have to write a schema. Okay, schema means, let's say I'll be using a large language model, and you know that we can also provide some parameter to the LLM, like prompt, maximum length, temperature value. Okay, these are the thing. So what I can do, I can create a template, schema template, and from there I can get that particular, let's say, information. So for this, I'll be using Pydentic library. So you can see Pydentic is a library in Python, and I'm importing something called base model. So here I'm going to create a class. So the class name would be generate request, and I'm inheriting with the base model. And inside that I have some parameter like prompt, maximum length, and temperature. So prompt I'll be taking from the user. Maximum length, it is already set, and temperature, it is also set. I think you know these are the parameter, right? Temperature means this is the creativity like parameter of the large language model. Then I'm going to create another class. So this will give you the generation response. Okay, that means whatever generated text your model will try to return, it will try to return, okay, with respect to this particular class. Now this schema is ready. Now we'll be writing the model loader. So inside model loader, what we'll do, we'll just try to load the model. So here I'm going to load one model called GPT-2. So here, if I go to the Hugging Face, so here you will see the model section. Now here, what you can do, you can search like GPT-2. Okay, GPT-2. See, this is the model will be loading. So how to load this model? So here you can load like that. First of all, import the pipeline from the transformer. Then you can load the model like that. Okay, so here this is the text generation model. So here in the pipeline I'm given text generation. Okay, because I want to perform the text generation, and GPT model I'm loading, GPT-2 model I'm loading, and this will give you the generator object. Okay, so once it is done, now I'm going to write the main file called main.py. So here, first of all, we'll be initializing the FastAPI, and we'll be importing all the necessary library. So you can see I'm importing the FastAPI, and from the schema I'm importing this class and this class. Okay, both I'm importing, you can see. Then from the model loader, I'm loading my generator model object. Okay, so once it is ready, I'll be initializing the FastAPI. So I will give a title actually like LLM Inference API, and you have to give like that. Then I'll be creating a default route. So once you hit the FastAPI, now you execute the FastAPI app, it will launch this particular route. Okay, so here you will be getting one message called LLM Inference API is running. Now let me show you. To run this, open up your terminal, and this is the command. So Gunicon, EVCon main because we are running the main.py file, and inside that we have app. Okay, our Flask fast API we have initialized as an app, so we are running app and -hyphen reload. Now if I execute, you will see that your application would be running. It is running on localhost port number 8000. Now if I come here and search for localhost port number 8000, okay, 8000, so you'll be able to see that message. LLM Inference API is running, and it will download the model. Okay, for me, my model got already downloaded, the GPT-2 model. But if you're doing it for the first time, you will see one loading option. Okay, model will be downloading from the internet. So everything is running fine. Now we'll be writing the main route. Okay, the route a user will hit to get the generate response. So this is the route, guys, I have created. And all the code example you will be getting from the FastAPI documentation they have given. Okay, like that's how we have to create the route. So this is the route, guys, generate. So once you hit the generate routes, what it will do, it will run the generation model, and it will get the prompt, max length, temperature, and number returns a sequence. Okay, now prompt I will be getting from the user. Okay, there will be getting an input box. From there will be give the prompt, and prompt will come here. That's why we are using the pydantic class. Okay, now once I got the generation response, I will also try to show in the FastAPI console. So now let me show you how it will work. So for this, I'll come here and I will try to reload. Now here you have to give /docs. So see, this is the interface of your FastAPI. Okay, by default you'll be getting a web app like that. Now this is the route I'll be hitting. Now here and this is the post request. Okay, you have to get the post request. Now click on try it out, and here you can pass the prompt. So let's say prompt wise I will give once upon a time. So it will complete the text because it's a text generation model. I can also change the max length and temperature parameter if you want. Now if I click on execute, so it will give me the response. So guys, here I got the response. You can see generated text. So once upon a time, okay, our university was ruled by the by one man, and blah blah blah. That means it is giving you the complete, okay, completion of that particular sentence. Okay, so that's how, guys, we have created our custom API, and we can hit any kinds of route right now. Okay, and we can easily do the inference with our large language model. So I hope you guys you got it. So very easily and very quick way we can create these kinds of API with the help of FastAPI. So we need this particular concept, guys, because going forward, whenever you will be creating the application, definitely you have to do the inference, and with the help of FastAPI you can easily create the API inference, okay, for your LLM. So yes, guys, this is all. I hope you got it. Now you can try with different model, and you can create your own API. So thanks for watching, guys.
So let's try to set up this MLflow server on top of our EC2 instance. So make sure, guys, you have the AWS account. For me, I already have. If you don't have the account, so please try to create one account. You have to add your card, okay, and initially it will deduct actually very less amount of money, at least 2 to 3 rupees, and you will be getting $300 free credits. Okay, so once account is ready, then you will be getting this kinds of window, okay, after login. So here what I need to do, first of all, guys, I already mentioned here. So here if you go to this GitHub link, so in the readme file I already mentioned, first of all you have to log into the console. I already logged in. Then you have to create the IAM user with the administrator access. Okay, so let's try to create the IAM user. So I'll go inside my AWS, and make sure you selected your region. So I am inside US East 1, that means North Virginia. So if you are in other region, you can select that one, but I will suggest go with this particular region. Okay, US East 1. So here I will search for IAM. So here click on the user. So previously I already created one user. So what I can do, I can delete it, or let's keep it. Okay, I will create a new user. I'll give the username, let's say MLflow server. Okay, I'll click on next. Then you have to add the policy. So click here, attach policies directly. Now here you have to select the administrator access. Okay, now below you'll see one button. Okay, next. I think you can't see because of me, but just right hand side below you'll see there is a next button. Just try to click here. Then after that you have to create the user. So right hand side again below you will see the create user option. Let's try to create the user. So guys, as you can see, I have created the user. So let's go inside that. Now click on the security credential, and here you will see one option called access keys. Okay, so click on the create access keys, select the command line interface CLI, and I understand the above recommendation, then click on next. Okay, so here let's create the key right now. So this is my access key and this is my secret access key. Okay, and you need it to authenticate with your accounts. Fine. So I will download as a CSV file because later on I also need that. Got it? Okay, it's completed. Now what I will do, guys, now again I'll get back. Now it is telling export the credential in your AWS CLI, AWS configure. We'll do it later whenever we'll execute the code. That time we'll try to do. Then I have to create the S3 bucket. Okay, S3 bucket to store my artifact. Okay, that means whatever artifact would be generated, let's say my model. Okay, and I think you saw the MLflow. MLflow also registered the model, right, with all the configuration and all. So everything will actually track in the S3 bucket. Okay, everything, all the artifact will save in the S3 bucket. So for this we have to create the bucket. So let's create the bucket. I will go to the AWS, and here you can search for S3. So this is my S3. Now let's create a bucket. So here give the bucket name. So here I will give MLflow. Okay, MLflow bucket and 25. Okay. You have to give a unique name, otherwise it won't be working, because S3 is a global service. So you have to take the unique name. Then everything just keep it default, no need to change anything. Or you can also remove this option, and I acknowledge. Then I will create the bucket. So guys, as you can see, my bucket has also created. Okay, now the next thing what I have to do, I have to create a EC2 machine. Okay, then we have to set up our MLflow server. Okay, inside that, and we have to add the port number there. We have to do the port mapping. So how to do it? Let's do it. So I'll get back to my AWS, search for EC2. So here let's launch one instance. I'll click on launch instance. Then let's give the name. I will give MLflow server or MLflow machine, anything you can give. So let's select the Ubuntu, and the LTS version I will take this one, 24.04, and the instance type, let's take at least 4 GB RAM. So I'll take T2 medium instance. Okay, you can select the key value pair. If you don't have, you can create it. Okay, let's create one. So I'll give, let's say, MLflow, and let's create the pair. So you need this particular PM file whenever you want to access your machine through some third-party tool like Putty and MobileStream, but I'm not going to use them. I'm going to directly open my terminal, okay, in the AWS console itself. I'll tell you, okay, how to do it. But it's a mandatory to select here, otherwise it won't be working. That's why we have created. Now let's allow HTTPS and HTTP traffic from the internet. Now configuration storage here, let's at least take 30 GB. Okay, 30 GB, or we can also take less than that, but let's take 30 GB. So once this is done, right hand side below you'll see one option called launch instance. Okay, just try to click here. So yeah, it will launch the instance. Okay, now I'll click on view all instance again, beside me. Okay, beside my video you will see the view all instance. Just try to click here. Now see, your machine is running. Okay, now what you can do, go inside the machine and there is a connect button. Okay, just click on the connect and let's connect the machine. So it will open up a black terminal for you, and inside that we have to set up all the configuration one by one. So all the commands I have mentioned here, so you can copy one by one and you can execute. Okay, I'll tell you how to do it. So this is my terminal I got. I think you can see. Now let me install everything one by one. First of all, let's update my machine. I'll copy the first command and let's execute. It's done. Now let's copy the second one. So we are installing Python here, and I'll give the yes permission and press enter. So it's completed. Now let's copy the second one, sorry, third commands, and let's execute. So I'm installing pip env. So again give y to continue.
Okay, it is also done. Now I'll copy the next one. I need virtual in env. Okay, then let's create a directory called MLflow. Now I need to go inside that particular directory, and inside that I'm going to install the MLflow with the help of pipenv. Let's install the MLflow. So it's completed. Now I'll install the AWS CLI, because I have to access my S3 bucket. Okay, because your MLflow will store all the artifacts in the S3, so it has to communicate with the S3 from the EC2 instance. So to make the connection, I need AWS CLI. There I will add the credential. The credential I have downloaded, AWS secret key and access key. With the help of that, it will configure. Okay, so let's do it. Okay, so it is also done. Now I will install something called Boto 3. So let me install Boto 3. So Boto 3 helps us to actually communicate with the AWS, okay, client. So let's install Boto 3 as well. Okay guys, so I installed the Boto 3. Now let's activate my shell. So MLflow has been activated, you can see. Okay, let me clear the terminal. So yeah, now I'll do the AWS configure. That means I have to set my access key and secret key. So let's do it. So it is asking for the access key. So where you will get the access key, guys, remember? So we downloaded one CSV file. So this is the CSV file. Let me open in a editor, and make sure, guys, you keep this particular secret file safe. If you are sharing with anyone, they will be able to access your machine. So here I'm showing you because after the recording I'll try to delete it. So let's paste. So this is my access key ID. Now I have to give the secret access key ID. So again, this is my secret access key ID. I'll copy, and here let's try to paste. Now it is asking for the region. So I told you I'm inside US East 1, that means North Virginia. Okay, so I have to give the same ID. So let's write, it should be US East -1. You are giving the same name, okay, otherwise it won't be working. Now it is asking for the output format. I'll keep default, press enter. So my credential has been set. Now finally we can start the MLflow server. Okay, finally we can start the MLflow server. So to start the MLflow server, this is the command you have to execute. Okay, but here you just need to do one modification. So here you have to give this S3 bucket name. So I think, remember, we created the bucket. So let me show you my bucket. I'll go to the S3. So this is my bucket name. Okay, MLflow bucket 25. I'll copy, and here I'll try to paste it. Okay, now this is the command you have to execute, guys. Okay, let's copy, and in my machine I'll execute the command. So it should work. Let's see. But one thing, this MLflow runs on this port number 5000. Okay, but we haven't set the port number 5000, so you have to do the port mapping. How to do it? Go to the security, and here you will see one option called security groups. Then right hand side you can see edit inbound rules, and let's add one rules here. Then I will select custom TCP and port number 5000. Okay, then select the 00. That means you want to access this machine from anywhere. And right hand side, just beside me, you will see one option called save rules. Okay. So my 5000 port has been set. Okay, now what I need to do, I need to go inside my instance. So this is my instance, and here you will see one option called public. Okay, IPv4. Okay, this particular URL, just try to copy, and here you can paste. And just after that you have to give clone 5000. Okay, now if I hit enter, so it should open my machine, but it won't be opening because here it is opening HTTPS. Okay, okay, sorry, it has opened because by default, see, if I copy the URL, one thing I want to tell you,
And if I paste in a different window, see it is HTTP, but if you if it is coming HTTPS, okay, that time you have to remove the S, okay, then you have to press enter, then it will open the MLflow server, okay, otherwise it won't be working. So once MLflow server is open, you will be getting this kinds of window, and if you are getting this kinds of window, congratulations, you have successfully installed MLflow in your EC2 instance.
So guys, we have set up our MLflow server on the AWS cloud and it is running. Now what I will show you the demo of this MLflow experiment tracking, how we can track actually experiment. So mostly we'll be using this MLflow whenever you will be training any kinds of large language model, okay? And you will be tracking the experiment. Let's say you want to track the parameters, you want to track the metrics, even you want to restart the model there, okay? So for these guys, what I will show you, I'll show you actually some practical demo. I think after that this part would be more clear. So first of all, let's try to see this particular practical demo. So here first of all, let's try to install the MLflow on the Google Colab. Okay, you can also set up in your local machine, okay, but I will use the Google Colab here. So here after setting it, what I will do, I will show you how we can actually, let's say, track how we can log actually different parameter, how we can log different metrics to the MLflow. Got it? So first of all, let's connect this notebook and make sure you select GPU, okay, as a runtime, because here we'll also try to, let's say, load the model. Okay, I will also try to, let's log the model. For this we'll try to select the GPU machine here, and all the resources I'm going to share you can download and you can practice. So let's install the MLflow, NumPy, Plotly, Pandas, okay, and transformers. These are the packages one by one. So guys, you can see our installation is complete. After that, you have to restart the session. Okay. Now let's install Boto 3 and AWS CLI, because I have to set the AWS credential in the Google Colab. Okay. If you want to authenticate. So for this, I need this AWS CLI and Boto 3. Okay. Now how to do it? You have to run this command AWS configure. So this will ask for the AWS access key ID. So I think you remember we downloaded one CSV file. Inside that we have AWS access key ID. I'll copy, and here let me just paste it, then press enter. Then it will ask for the secret access key ID. So this is our secret access key ID. I'll try to paste it here. Now press enter. Now it is asking for the region. So region is US East 1. Okay, based on your region you can give here. Now output, just press enter. Okay, now everything is set. Now you have to set the AWS tracking URI. So what is the tracking URI? You can see your URI. This is the AWS, this is our MLflow URI. Let's copy this URI, and here let me mention it. Previously I was doing with my local machine, that's why this is the local host I have given. Okay, now here this is my URI. Okay, so now let's set the URI. Okay, so URI is set. Now guys, we'll try to create and manage the experiment right now. So first of all, let's create an experiment. See, previously by default you have default experiment. Now if you want to create a new experiment, you can also do it. For this this code you have to execute. Let me show you. So this code you have to execute. So this will create the experiment. Okay, now if I come here, if I refresh, so guys, your experiment has created. Okay, and inside experiment it has created one branch. Okay, randomly it has created one branch. But if you want to assign this run, okay, let's say I want to assign the run name, so I can also do it. So this particular code you have to execute that time. Okay, manually creating the custom run. Let's say I want to create as a first run. Okay, so what I will do, I'll execute it here. Now if I come here and if I refresh, there is a refresh button. Or let's refresh here. So see, first run has created. Okay, so that's how you can either create randomly, either you can create as per your choice. So once run is created, now I can log any kinds of parameter here. To log any kinds of parameter, you can use MLflow log underscore params. Okay. I think you know whenever we train the model, we have different parameter like learning rate, batch size, okay, number of epoch, then and so on, right? So these are the parameter we usually log. We usually use, okay, whenever we train any kinds of large language model. Let's say I want to log these are the parameter, I'll be using log params that time. Okay. Now if I execute, you'll see that parameter would be logged. Now if I come here, if I refresh, so it has logged inside my first one, okay, the latest one. So you can see our parameter has been logged. Okay, you can see parameter section. So we have logged 3 parameter here. So that's how we can like log different parameter. Now let's say you want to log any kinds of metrics. So I think you know that after training the model, we also get different metrics like accuracy score, F1 score, and so on, right? We can also log it. Then we can also have we can also log the loss metrics, right? So every epoch it will give you the loss and accuracy. So here I've created a dummy, let's say accuracy and loss with respect to the numpy. I'm generating some random number and I'm logging them, okay, into a for loop. The number of epoch I have given 10, so 10 times it will run and it will save some accuracy and losses. Now if I come here, if I again refresh, so you'll see that some metrics has been saved. Okay, you can see. Now if I want to show you the model metrics, you can see this is the like accuracy and this is the losses. Okay, you can see as a graph. So this is the beauty of this MLflow. Okay, everything you can visualize here. Now what I will do, I will show you how you can log any kinds of artifact. Okay, let's say you want to log any artifact. Artifact means any kinds of data. Let's say you have a data, you want to log that. So what you can do, you can use log artifact that time. So what it will do, it will take your data. So as of now, I don't have any data here, but if you want to save your data, let's say going forward, I'll be training the model, and if I want to log the data, so I'll be using the log artifact that time. Okay, so if you execute this code, only just need to give that like data locations. Okay, it will log that data to the S3 bucket. I think you created one S3 bucket, remember? So here it will save that particular data. Okay, so this is like another way you can log the artifact. And or not only data, you can log any kinds of, let's say, image, any kinds of txt file, whatever. Let's say anything you want to log here, you can log it. Now logging the model. Okay, how to log the model? So to log the model, you can use log model function. Okay, that time, let's say I want to log this model, actually one large language model from the Hugging Face. You can see this model actually I want to log. So this is a Amazon product review model. It's a text classification model actually. So you can see this is the model. Okay, now let's say I want to log this model. So what I will do, I'll first of all load the model, then I will use MLflow, and this is the PyTorch model. That's why you have to use .pytorch. Okay, if you want to log any TensorFlow model, you have to use TensorFlow. Then log underscore model, you have to give the model object and you have to give the name. Okay, so here I have given transformer model. Okay, transformer model, this is the name. You can give any kinds of name. Okay, with that name it will log the model. Now if I execute, so first of all it will download the model, then it will log it. Let me show you. Now see guys, it is getting downloaded. Okay, so after downloading it will log the model to the MLflow. So guys, you can see execution is done. Now if I go back to the MLflow, now if I refresh, so see, you will be able to see the model. So if you want to see the model, go to the artifact, and here is the model guys. Okay, transformer model, we have given the name, and inside that you can see some model configuration file, and to use the model, what are the requirement you have to install, everything it has also saved. The environment you have to create, it has also created. On the environment dependency, it has also created. Okay, and in the data folder you have the model.pts file. Okay, so that's how guys we can also log the model, and this model we can use it later on, okay, for the inference purpose. So guys, I think you got it, how we can use MLflow for the experiment tracking, different experiment. Okay, and see what is the beauty of this MLflow. Let's say you are training a model, okay, with a different parameter. You can log real time, and later on you can compare which model is working better. Even you can also do the model version controlling with the help of model registry. That thing I will show you, okay, after that. So there you can compare different model with different parameter, with different let's say accuracy or let's say losses. Then you can select the best model out of it. Okay, this is the beauty. Now let me show you one training demo. So what I will do, so this is another notebook guys I have. So first of all, let's connect this notebook. So here I will try to train one LLM, and I will try to log the parameter, okay, real time. So it's connected now. First of all, let's set up all the necessary library. Then you also need to set up this Boto 3 and AWS CLI. Then after that, you have to configure. So let's wait. Once the installation is complete, I'll come back. So guys, as you can see, it's done. Now let me restart the session. Okay, so here one issue I'm getting. Okay, let me first of all execute and see. Let's say I'll execute this line. So it should import everything. Okay, so it is giving me one error. So what you can do, so one thing I can do, just let me check the previous version I was using here, 4.3. This one, let's try to install. Now again, let's restart the session. Now let me put. Okay, so now it is working. Okay, so you have to upgrade to this version, then it will be working. Now let me install the Boto 3 and AWS CLI. Okay, now let's configure the credential. AWS access key ID, secret access key ID, then region US East 1, and press enter. Okay, done. Now let me okay, so I have already imported. Now let's create some parameter like the model name I want to use. So here we'll be training one text classification model. Okay, so that's why we'll be training DistillBart best case model. So this model is available on the Hugging Face. So let me show you DistillBart best case model. So this is the model we'll be using, guys. Okay, this model. Yeah, and learning rate I have given, batch size, number of epoch, dataset name I'll be using AG news dataset. Okay, it's a news classification model we'll be training. So here you can see sequence task name I want to assign as a sequence classification. What's the task name? Task name means, let's say to the MLflow, it will create the task name. Okay, so it will create the experiment name like that. So this name actually I have given. Then log steps, maximum sequence length, and output directories. Okay, where it will save all the, let's say, logs and all. So here this is the output directories. So I believe that, guys, you already trained these kinds of model before. Okay, these kinds of large language model before with the help of Hugging Face. Okay, so now let me set the tracking URI. So let's copy our tracking URI. So maybe I can copy from the previous notebook. So this is the tracking URI. So yeah, we'll set the tracking URI and we will create the experiment name. Okay, experiment name is our task name. Task name is, this is sequence classification. It's done. Now if I come here, if I refresh, so you'll see that another experiment will be created, sequence classification. Inside that, there is nothing. Now see what we do usually whenever we train any kinds of let's say model with the help of Hugging Face. First of all, we like to load the data. Okay, and which data will be loading? Data set, this data, AG news data. Then after that, we'll be performing the tokenization. Tokenization means we'll be generating the embeddings. Okay, that means the vectors, and that vector will try to pass to the model. So this is the function I have written. So this will create the embeddings. Okay, and it will return you. After that, we'll try to actually create the data sets. You can see we are doing the shuffling operation. So we are taking some example after doing the tokenization. Then we are setting the format as a PyTorch, because this is a PyTorch model. That's why you have to set the format as a PyTorch. Then after that, we have to use the data loader. I think you know that if you're using PyTorch, you have to use data loader, okay, to load the data. Then once it is done, we are also extracting the labels. Now let me execute the entire code. So these steps are common, okay, for all the training. So see, all the tokenization is happening. Okay, execution is done. Now if I want to show the label, so see, these are the labels you have in the data. Now guys, what I will do, I'll initialize the model. So here you can see I'm initializing the DistillBart model, and we are setting the this label, okay, to the model. That means we have to create the configuration file. For this we use this particular, let's say, code snippet. Okay, now we are also detecting our device, whether we are using GPU or CPU. So maybe let me check uh, runtime. Okay, so here we have selected the CPU, guys. So what you have to do, you have to select the GPU. Okay, GPU, then set. Then again you have to do the same thing, because I forget to set the GPU. Okay, that's why I'm doing it again. Okay, now let me reconnect the notebook and let's install again everything. So at the very first time, guys, you have to select the GPU. Okay, I forget to do it. Extremely sorry. Now let me install. So again, I will execute all the line quickly. Okay. Okay, done. Now let me import all of the library. Okay, so here it is throwing me one error. Okay, so guys, you can see it's working fine now. Now let's execute this line. We'll be say installing Boto 3 and AWS CLI, then we'll be trying to configure everything. Reason US East 1. Enter. Done. Now let's initialize the parameter. Now I think we have already created the experiment. Let me again execute. Okay, this created. Now if I come here, refresh, okay, it is already created. Now let's execute this code. Okay, I think this will work. Then these are my labels. Now we'll try to initialize the model and we'll be detecting the device. So here we have selected a GPU, that's why it will take the CUDA, and we are loading the model in the GPU. Okay, done. Now this is our model. Okay, now we'll be initializing the optimizer. We're using RMW optimizers. Okay, now this is the evaluation function. So if you go to the Hugging Face documentation, you will be able to see this function. Okay, so what it will do, it will do the evaluation of the model. Okay, it will take the test data and it will do the evaluation on top of that. It will return you accuracy, precision, recall, and FRD score. Okay, these are the metrics. Now this is the training loop, guys. Okay, you have to execute the training loops, and to start the training loops, guys, you have to initialize the MLflow like that with MLflow start run. Okay, and inside that you have to give the run name. And what would be the run name? Run name would be model name, and you are also concatenating the dataset name. Okay, this is your run name. Run name means here it will create up one run name. Okay, so after that it will start logging the parameter. All the parameter you will log. Okay, whatever parameter you have mentioned, I think, remember here. Okay, these are the parameter it will log. Then after that it will start the training. You can see it will load the data. It will calculate the losses and everything. It will do the back propagations. After that all the steps you will be able to see that. Then once you got the let's say accuracy, precision, and recall after running the evaluation model function. Okay, so what you have to do, you have to also log that. How to log metrics? I think I showed you now. To log the parameter you have to use the log params, and to log the metrics you have to use the log metrics. Okay, then you have to save the model. So once everything is set, then you have to also save all the outputs. So whatever outputs you got, so you have to save as a artifact. Okay, so here you can see I'm saving as an artifact. Then I am also taking the model URI. Then we are registering the model to the MLflow. Okay, now let me execute the entire code. So guys, you can see our training has started. So this training will take some time, guys, because here we have lots of data. So I'll pause the video. Once this training is complete, I will come back. So guys, as you can see, our execution is complete. Now guys, execution is complete. Now if I come to the MLflow, if I refresh, now you'll be able to see the runs. You can see this is the runs. Okay, I got it. If I go inside that, you can see all the parameter. Okay, we have logged. Even the matrices I also got. Now you can also visualize the metrics. Okay, we just run only one epoch, that's why it's coming like that. Okay, but if you run multiple epoch, you will be able to see like more good visualization. Okay, now you can see this is the loss. That means as per your epochs is increasing, loss is also decreasing. That means my model is learning better. Okay, now if I go to the artifact section, so you can see guys models. So see some of the model parameter it has also saved. Now guys, if I show you the models, okay, go to the model because we have also done the registration. So if I go to the model, so model registration is also done. So see guys, this is the model. Okay, and this is the version 1 of our model. Now if you run it for the second time, okay, with a different parameter, it will again create another model. That's how you can do the model tracking also. This is another beauty of this MLflow. Okay, now you can see guys, this is our model. Okay, this is our model, and this is the registration date and timing, everything it is showing me. Now from here also we can do the inference, okay, by loading the model. So let me show you. So one thing I want to show you, if you go to your S3 bucket, okay, so let's say this is our bucket. So it has also saved your artifact there. See, that means your model is available. Okay, here you can see this is your model. Now I think one local folder has also created. left hand side, this is the model. Inside that you have your DistillBat model. Okay, so that means all the artifact it has saved to the S3 bucket also. Now everything is working fine. Now in the next video, we'll try to see how we can perform the inference operation with this particular model. Thank you guys. Hi guys, so guys, we have seen like how we can track the experiment over the MLflow. Okay, so this is the entire training demo I showed you. So one thing you have to do guys, because I was having some issue later on, see whenever we are training na, so this training loop, so that time you have to activate this two line. Okay, so I think I told you about this particular, let's say, code. So you have to also activate this two line, otherwise what is happening, ML model is not getting it is getting registered, but there is one file is getting missing. Okay, so if you want to get that file, you have to activate this line, then actually this is working. So let me show you what is the file I'm talking about. So let's say if I go to my experiment, so see I did another experiment here. So if I go inside that, so if I go to the artifact, now if I open my ML folder, sorry, a model, now see here this ML model is missing there. Okay, so this particular file should be there, otherwise this will give you one error whenever you will be loading the model, okay, from the MLflow. So that's why you have to activate this line. Okay, then again retrain the model. Okay, and you will be able to see it is working fine. Okay, so guys, I have already trained another model, and you can see this model got also registered here. Now let's say I want to do the inference. Okay, because this model is already serving here, you can see. Okay, this model is already serving, and this is the version 2 of the model, because later on I train another model. Okay, this is available here. Now I can load this model and I can do the inference operation on top of that. How? So again, I created this notebook guys, and I will share in the description section. So you have to do the same thing. First of all, install the MLflow and transformer. Then after that, install the Boto 3 and AWS CLI. Then I try to do the configuration. Okay, and see if you get this transformer library issue after executing this code, so you can execute this line. Okay, because it will install the latest version of the transformer. Then just try to import all the library. Then try to set the URI, and after setting the URI, you have to make the MLflow client. And to make the MLflow client, just write MLflow.tracking.MLflow client. Okay, now once it is done, then you have to give the model name. So here this is the model name. I think you remember, if I go inside registered model model section. Okay, so here go inside experiment models. Okay, see this is the model name. Just try to copy the model name, and here just try to pass it. Okay, and the version, which version you want to use. So previous version, actually I had some issue, that's why I'll give the second version. Okay, so number 2 version. Now you have to create the URI. How to create the URI? I have given the f string models. Okay, model name / model version. Now you have to use model MLflow.pythos.load model, and you have to pass the URI. Okay, if you pass it, what it will do, it will try to download the model from the artifact. Okay, that means this model is already available where it is available in the S3 bucket. Okay, so it is available in the S3 bucket, I think, remember. So from the S3 bucket, this model would be downloaded. Okay, downloaded. Then after that, we can do the inference operation, and for this is the predicted function I have written. So this will take the model as well as the tokenizer. Then what it will do, it will try to pass the text, whatever text user will pass. It's a classification model, I think you remember. We'll give some classification data and we'll try to classify. Okay, then you can see this is the prediction I am doing here. Then after that, I'm returning the prediction. So this function I have written, guys. Now guys, here I have some sample text. Let's say here I have some news, you can see. Okay, news category. So now I have to classify what particular category is it. So let me execute. Now see, I have to download the tokenizer again, because I have to convert this text to numbers. Okay, and how to do it? With the help of the tokenizer, the same tokenizer. So I'm downloading the tokenizer, you can see. Then I'm passing the text, the model I have loaded. Okay, you can see the model I have loaded, and the tokenizer I'm passing. Now if I execute, see it is giving me world and wild, because how many category you have here, I think you remember. So in the label, so you have world, sports, business, and sci tech. Okay, so this particular news is getting categorized by world, both news. Okay, both news, if you read, it's a world category. Okay, so that's how guys we can do the inference operation with our MLflow model. That means this model is serving right now here. Okay, and you can use it. And if you want to clean up all the models and versions, you can execute this particular code. It will delete everything, guys. Okay, so yes guys, that's how we can perform the MLflow inference. I think you got it, the entire demo. Okay, how we can use the MLflow for the LLMOps purpose. And again guys, this is one of the amazing tool you can use. Okay, whenever you are doing any kinds of fine tuning, whenever you are doing any kinds of inference operation, you can do it. So here you can use any kinds of large language model. I showed you with the help of DistillBat. You can use any kinds of large language model, whether it's a Llama Falcon, okay, Mistral, anything you can use. Now let me show you how we can terminate all the instance. So here you can see my MLflow is running. Now if you don't want to keep it running, what you can do, you can stop the, like, you can delete everything. So for this, first of all, let's go to the instance. Now select the instance, and what you can do, click here, instance state. Now terminate the instance. Okay, so terminate means you are deleting everything. Okay, deleting. And stop means you are stopping it, and stop means it will charge you for the storage service. Okay, and terminate means you will be completely deleting from here. Then after that, we'll try to also delete the bucket. So for this, what I will do, I'll come here. So let's say this is our buckets. Inside that I have some file. First of all, let me delete. So I have to give the permanent delete option. Now I'll go back to my bucket, and this is another file I have inside that. Let me delete also. Now my bucket is empty. Now I can delete the buckets. Okay, so come here, select the bucket and delete the bucket. You have to give the bucket name. Yeah, so everything is deleted. Now I have to also delete the IAM user. So let's go to the IAM, and here is the user. Just try to select the user and delete. So MLflow user. Okay, so everything has deleted. Okay, so all the resources I will share, guys. From there you can try. So yes, guys, this was the MLflow, and I hope you got it. Thanks for watching. Hi guys. Now I'm going to show you how we can build CI/CD pipelines with the help of GitHub Actions. So see, whenever we have to do the deployment, mostly we'll be following the CI/CD approach. So what is the benefit of CI/CD approach? I'm going to explain each and everything. Okay, why you should use the CI/CD approach. So in this video, I'm going to use one of my project called Medical Chatbot. So I already uploaded that source code to my GitHub. Okay, so make sure, guys, I will share my code with you. Just try to download the code, and you just try to upload that particular code to your GitHub. Okay, make sure you are uploading in your GitHub, not in my GitHub. Okay, because you can't access my GitHub. So just try to commit the code in your GitHub. Then whatever process I'm going to show you, just try to do the same thing. You will be able to deploy this project. Okay, that's a CI/CD pipeline. So I'm going to show you the entire steps how you can perform the CI/CD. So here I'll be using the AWS cloud for the CI/CD deployment, and as a CI/CD tool I'll be using GitHub Actions. So first of all, let's try to understand why CI/CD is important. Then I'm going to show you how we can deploy the entire projects over the AWS cloud.
So guys, as I already told you, here we'll be doing something called CI/CD deployment, right? And I already told you what is CI/CD full form. It's continuous integration, continuous delivery, or deployment, right? So inside continuous integration, continuous delivery, what happens? Let's say you are the developer. Okay, let's say you are the developer. So what is your task? Your task is to develop a project in the development, let's say, environment. So development environment means like your local system. Let's say you are using your laptop or computer. Let's say local computer. Okay, local computer. Fine. Then what we are doing, I think you remember, we are committing this code to the GitHub, right? We are doing the code management. I think you remember. That means whenever I was adding some new feature, I was pushing this code to the GitHub. Yes or no? Okay, with the help of Git client, we are pushing the code in the GitHub server. Now what happens actually, let's say after deployment. So this is called actually development server, or I can write this is actually development environment. Okay, development environment. So after implementing this project, what we have to do, we have to deploy this project, yes or no? Let's say somehow you have deployed this project on the AWS cloud. Let's say this is your AWS cloud. Fine. So let's say you have deployed this project to the AWS cloud manually. You just created a, let's say, instance there. You just took a machine there, a EC2 machine, and you manually deployed this project. Now it will give you some endpoint. Okay, endpoint. So with the help of this endpoint, any of the user can access your application. Now let's say after 4 months or let's say 6 months, you want to add some more features in this, let's say, application. Let's say you are deploying medical chatbot. The medical chatbot we implemented, I think you remember, right? let's say you want to add some more data, you want to add some more knowledge base, and you want to add some more features in this application, then what you have to do, you have to again develop this, let's say, features in your code. Then what you will be doing, again you will be deploying this application to the AWS cloud. Now just try to see, whenever you are deploying the project for the second time, let's say this is the first time you have deployed, then you are trying to deploy for the second time, then what you have to do, first of all, you have to stop this application in the AWS. Okay, stop this application, then you will be uploading your updated code. Then this code will reflect to the endpoint, then user will be able to access that. Now let's say in between, whenever you stop this AWS server, let's say your application, let's say it took 3 hours. It took 3 hours to change the entire source code. That means change the entire features, okay, of your application. So what will happen? 3 hours user won't be able to access your application. So they will come your website and they will see server error. Okay, server error actually they will get. So if user is getting this kinds of experience, so definitely it would be a negative, let's say, effect, okay, on your application. So next time actually they are not going to use your application. Yes or no? Let's say if ChatGPT is down for the let's say 3 hours, definitely people will move to the Google Bard or any other, let's say, software, whatever actually we are having. Okay, so now see, ChatGPT is also updating their, let's say, application day by day. But did you ever observe this server is down? No, you are not seeing this server is down, but still they're able to make the changes in their application. How? Because they are following something called CICD approach, continuous integration, continuous delivery. That means this application is keep on running, but in the backend they're pushing their source code, they're pushing their, let's say, new features, and this feature is automatically getting updated. Okay, so this is called actually CICD. That means you are not going to deploy this application manually. Instead of that, what you have to do, you have to follow the CICD. That means what will happen? Let's say you have changed something in your code, you will push the code to the GitHub. Okay, GitHub will automatically let's say deploy your code to the AWS cloud. It will automatically push your code to the AWS cloud, and your endpoint would be automatically updated. Okay, automatically updated, so that if user is using your application, okay, they won't be feeling any kinds of, let's say, server down issue. Okay, server down issue actually they won't be feeling. Got it? So this is what actually we have to do. That means we'll be creating the entire pipeline, entire, let's say, CI/CD pipeline. So we'll be just pushing the code in our GitHub, and GitHub will automatically trigger this action, and my code will update it to the AWS cloud, and AWS will update the endpoint. Okay, now see, the automated process we'll be doing. Now whenever we'll let's say push our code to the GitHub, GitHub will automatically trigger. How it will trigger? For this you have to use some CI/CD tool. Okay, CI/CD tool, CI/CD automation tool. So here there are different kinds of CI/CD tool. So the first tool you can use something called GitHub Action. Okay, GitHub Action you can use. Then you can use something called Jenkins. Okay, Jenkins. Then you can use something called Circle CI. Circle CI. So these actually 3 famous tools actually we are having in the market right now. So people are using more this GitHub Action, because GitHub Action you don't need to set up anything. It is already set up everything in the GitHub. But if you're using Jenkins and Circle CI, you have to set up this server manually. Okay, so here we'll be using GitHub Action because it is already inbuilt with the GitHub. We don't need to set up anything. Going forward, I will also show you how we can let's say use Jenkins, Circle CI. These are the services as well. Fine. So yes guys, this is the complete high level architecture of our deployment. Now let's discuss what are the services actually we'll be using for the deployment. See, here the first services actually I'm going to use called Docker. So I think you already know Docker. So Docker is a containerization service. So with the help of that, you can containerize your code. That means, let's say you are having a source code, you can perform the containerization. That means it will create a Docker image for you. Okay, so this image you can let's say keep anywhere. Let's say you can keep in the Docker Hub, you can keep, let's say, in the ECR, that means Elastic Container Registry. From there you can pull the image and you can execute this image. Okay, so if you are using Docker, so you won't be getting any kinds of setup issue. This is the main advantage here. Then we'll be using something called ECR here. ECR means Elastic Container Registry. So this is the service from the AWS. Okay, AWS giving this service. So here you can store any kinds of Docker image. It is the same like your Docker Hub. Okay, but it is the service from the AWS. You can store the private image there, but in Docker Hub actually all the image would be public. This is the difference only. Now we'll be using another service called EC2. Okay, EC2 is a virtual machine service from the AWS. Again, it is from the AWS. Okay, so this will give you virtual machine. There you can buy, let's say, CPU based machine, GPU based machine. Okay, so all kinds of configuration would be there. So here we are using our local computer. So there we'll be getting a cloud computer. Okay, this is the difference only. Then as a CI/CD tool, I'll be using something called GitHub Action, as I already told you. Okay, we'll be using GitHub Action for the CI/CD management. Fine. So yes, guys, these are the services as of now I'm going to use. So let me show you the deployment step we'll be following. For this, what I have done, guys, I think you remember we implemented one medical chatbot. This is the code, and this code would be also available in your resources section. Now this is the CI/CD deployment we'll be following. So first of all, what I have to do, we have to let's say create a IAM user. Then we'll be creating the EC2 machine ECR. Okay, then we'll be, see, this is the deployment step as of now. Just try to follow this step I'm going to show you. First of all, we'll be building our so here, first of all, we'll be building the Docker image of our source code. That means Docker image we'll be implementing. Then we'll be pushing this Docker image to the ECR. That means Elastic Container Registry to store my Docker image. Then we'll be pulling this image from ECR in the EC2. That means we'll be pulling that image in the EC2 machine in our virtual computer. Then we'll be launching this Docker image in my EC2 machine, and from there we'll be creating an endpoint, and that endpoint user will be able to access. Okay, and these are the policy I have to give whenever I will be creating the IAM user. Fine. So this is the entire step, guys, I have written. Even I have also given all the command you need to execute here. Now let's start the deployment, guys. But before that, you just need to prepare some of the files. The first file you have to prepare the Docker file. So this file will help you to containerize entire your application. That means it will perform the Dockerization. And these are the Docker command you have to write. So I think you remember we are using Python 3.10. Okay, this Python version. That's why I have taken Python 3.10 Slim Busted image. Then working directory, it will create a working directory called app. Inside that, it will copy all the source code. Then it will install the requirements. Okay, whatever requirements actually we are having here. Got it? Then it will execute this Python 3 app.py command. So that means my endpoint would be executed. Okay, my application would be running. Now what I have to do, guys, then you can create another file called Docker ignore. Inside Docker ignore, you can mention like some of the file which is not required. Let's say here, this file is not required. Let's say, I think this file is not required. Generative AI project.egginfo. Okay. So whenever it will perform the, let's say, containerization, that means Dockerization. So I don't need this folder. That time what you can do, you can mention this folder name in the Docker ignore file. It is the same thing as your git ignore. So it is already mentioned inside my git ignore. That's why I haven't mentioned inside my Docker ignore. Docker ignore is completely empty. As of now, I need all the file. That's why I haven't keep anything here. Now let's see, if you want to ignore any kinds of file which is not required, that time you can store these other file inside Docker ignore. Okay, that's the thing. Now the next things you have to create. You have to create one folder called .github. Okay, inside that you have to create one folder called workflows. Inside that you have to create one YAML file. You can give any name. Here I have given CICD.yaml. Okay, now see, this is the complete YAML file. So this YAML file will help me to do the CICD deployment. Okay, that means here it will be using something called GitHub action. Okay, and GitHub action need this YAML file. So here all the command is already written. So first of all, you will see that it will perform continuous integration. Inside continuous integration, it will authenticate with my AWS account. Okay, then it will log in with my ECR. Then whatever, let's say, Docker image actually will be building, you will push that image to the ECR. Okay, that means Elastic Container Registry. Then your continuous deployment will start. Again, it will authenticate with AWS account. Then it will pull that, let's say, image from your ECR to EC2 machine. Then it will execute it here. And here all the environment variable I have set. You can see -e means this is the environment variable. See, AWS access key, AWS secret key. I'll tell you how to generate these are the key. Then a Pinecone API key, OpenAI API key, everything I have set here. Okay, so these are the thing we'll be reading from the secret. Okay, GitHub secret. I'll tell you how to create the GitHub secret as well. So as of now, just try to remember this is the YAML file you have to use for the CI/CD, and this YAML file you can use as it is. No need to change anything in your other project as well. Okay, that's the thing. Now let's open up our AWS account. So guys, this is my AWS account. I already logged in with my AWS account. So here, so first of all, what you have to do, you have to create a IAM user. So let's create a IAM user. So IAM. So the first thing we'll be creating one user here. So let's create one user. I'll create a user. So let's say username is, I'll give medical bot. You can give any name, it's up to you. So let's click on next. Now you have to give policies. Okay, like what are the policy you want to give in this user? I don't want to give my entire policy. That means all the services I don't want to give the access. So I'll be giving some specific access. So access wise, I already written in the readme file. Let me show you. So these are the access I'll be providing. My EC2 container registry full access and EC2 full access. Okay, these are the thing we'll be giving. So here just search it. So this is the ECR. Okay, ECR Elastic Container Registry full service here I'm giving. So let's select. And after that, again, I can delete it. Then I'll try to copy the next service. This is the service. Okay, this is the EC2 machine service. So again, search here and select the EC2 machine and click on the next. Now you'll see that I have given this to service. Okay. Next thing, just create the user. So right hand side, you can see one button is there, create user. Just click on create user. So guys, as you can see, my user has created. Now I'll click on the user. Then here you will get one option, security credential. Just click here. Then you have to create a access key. So click on create access key, select command line interface, and I understand this above recommendation, and click on the next. So there is a next button, just click on the next. Now create the access key here. Now see guys, this is your access key and secret access key. Try to download as a CSV file. So let's download. So and just keep it with you. Okay, this thing I need later on. Okay, and no need to share this key with anyone, otherwise they will also access your AWS account. Okay, so here I'm showing because after the recording I'll delete everything. Got it? So my IAM creation is done. Now I'll go back to the home page. Now the next thing what I have to do, guys, I have to create a ECR repository to store my Docker image. So let's search for ECR. So just search for ECR, that means Elastic Container Registry. Just open it up and make sure you check your region, in which region you are working. See, I'm working in Mumbai, AP South 1. If you're in other region, just try to note it down. Okay, you have to note it down, this syntax actually, AP South 1, then CA Central 1. If you're, let's say, in North Virginia, you have to give US East 1. So just try to remember these are the tag. Okay, so I'm inside Mumbai, that means AP South 1. Now I'll be creating a Elastic Container Registry. So let's create, so let's click there. Now you have to give the name. Let's say I'll give medical chatbot. You can give any name, it's up to you. Everything keep it as default. Now click on next. Now see, my repo is created. Now what you have to do, just copy the URI and just try to paste it as of now here, because this thing I need later on. Just for reference, I'm saving it here. Okay. That's it. Now what I will do, I will go back again. Now the next thing I have to do, I have to create my EC2 machine. Then I have to set up, these are the requirements. Okay, that means I have to set up the Docker there. Then I will be also updating that machine. So let's create my EC2 machine right now. So search for EC2 here, EC2 instance. So this is the EC2 service. Now launch the instance. Now select the Ubuntu machine. And what you have to do, give the name of the machine. Let's say medical bot machine. You can give anything. Then see, instance type, you have to take at least 8 GB RAM. 8 GB RAM, just take 8 GB RAM. I'll be taking T2 large. Okay, this machine. And then select the key value pair. If you don't have the key value pair, you can also create it. So let's say I'll give medical. So it will create one RSA file. So guys, you can see after creating and download, it will give you one PEM file. So this PEM file you can use. Let's say if you're using any third-party tool to connect with your EC2 machine, let's say Putty or Mobile Extreme, that time you can use this PEM file. But I'm going to launch my, let's say, machine in my second tab with the help of AWS only. I don't need this PEM file. Okay. So now I'll select these two options, HTTPS and HTTP. Keep it everything as default. Configuration storage at least take, let's say, 30 GB. And launch the instance right now. So here you can see, click on view all instance. Then see, my machine is running. So if status is running, now click on the machine ID. Now here you have to connect this machine. So click on the connect button. Now I'll be selecting the EC2 connector and let's connect the machine. So it will create a new tab for me. So here I will get one terminal, black terminal. So we have to use this terminal to set up everything here. And this is the production server, guys. Okay, that's how your production server looks like. See, this is the production server. Let me zoom. Now let me clear. See, here you won't be getting any kinds of UI interface. Okay, that means the way we are using our computer, it is having UI. But in the production server, you won't be getting any kinds of UI. You have to work with the terminal always. And this is the Linux terminal I got. This is the Linux machine, guys. So that's why if you know any kinds of Linux command, it will help you a lot. Got it? So here, first of all, I have to update this machine. For this, you have to execute these at the command one by one. So let's copy all the command one by one. Okay, so this is done. Now I'll copy the next command and just try to paste here. Now give yes permission and press enter. Okay, so execution is completed. Now I have to set up the Docker in the EC2 machine. So this is the command you have to run. Copy the next one and execute. Then I will execute this one, then the last command. So we have to add the Docker in the sudo group. Okay. Now if it is running or not, so what you can do, you can execute one command, docker ---- version. So if it is showing the version, that means Docker is installed successfully. Now we have to set up our self-hosted runner, EC2 as our self-hosted runner. That means we have to connect our GitHub. Okay, you can see this is the GitHub. Now this is our project GitHub. So this GitHub I have to connect with my AWS. That means whenever user will, whenever let's say developer will push the code in the GitHub, it will automatically get updated to the AWS. Okay, AWS cloud. So for this, what I have to do, I have to go to my project. Make sure you committed your repository in your GitHub and go to the settings. Okay, go to the settings. Now here, left hand side, you will see one option called action. Just click on the action, click on the runners. Now create a new self-hosted runner. Now select the Linux machine and you have to execute. These are the commands. So let's copy this command one by one and let me execute here. So it will automatically make the connection with your GitHub. Let me show you. Then the third command. Then fourth command. Now you have to go to the configuration section and copy this command and execute it here. Now see GitHub action, it will automatically connect. Now it will see it has connected to the GitHub. Now it is asking for enter the name of the runner group. I don't want to give anything, press enter. Now it is asking enter the name of the runner. So here you have to give self-hosted. Okay, self-hosted. This is the thing you have to give. If you're giving another thing, it won't be working. Okay, make sure you're giving self-hosted. Now let's press enter. Now keep it everything in default, just press enter again. Then again press enter. Now see, it is done. Now the last command we have to execute, this one. And you can ignore this one, it is not required. Now see, it would be connected with my GitHub. See, connected to the GitHub, listening for the jobs. Okay. Now if I show you, if I come back and now if I go to the runners, let's say, I'll go to the runners. Now see, status should be idle. You can see it is connected. Okay. Now the next thing what I have to do, I have to set up all the GitHub secrets. Okay. Now let's go back to the secret. So secret variable, click on the action. Now new repository secret. Now give the secret ID. Okay. So for the first ID I have to give AWS access key ID. Just copy and give the key name here. And why we will get the value? I think remember we downloaded one CSV file. So let me open this CSV file. I will open in a Notepad++, and this is my AWS access key ID. I'll copy, and here let me paste it. Then the next one I have to give secret access key ID, copy, and create another new repository secret and give it here. And in the CSV file, you will get the next one. See, it is comma separated. So before the comma, this is the AWS key ID, access key ID, and after the comma, this is the secret access key ID. So let me copy the secret access key ID and I will paste it here. Okay, now the next thing you have to give AWS default region. So region, I already told you I'm inside Mumbai. That means AP South 1. So I think remember I'm inside AP South 1. See, AP South 1, you have to write it. So let's write AP-South. Okay, -1, AP South 1. Let's try to check AP South 1. AP South 1. Okay, fine. Now let me add it. Now the next thing I have to add my ECR repo. So ECR repo wise, I think you remember we copied one URL. So just try to get this name only. Okay, after .com, just try to get the name and try to mention here. Then the next thing I have to set my Pinecone API key. So let's copy and add it here. And I think I remember in my .env file, I had my Pinecone API key. Let's copy. And this is not available inside my GitHub. That's why I'm reading from the GitHub secret. Okay, this is the idea. Now I also need to add my OpenAI secret. Okay, that means OpenAI API key. The last one you can see OpenAI API key. Let's add it. So let's copy the OpenAI API. Here I'm going to paste it. Now let's add the secret. Okay, now see everything is added. Now let me see anything is left. No, everything I have added. Now what I have to do, I have to push the changes. Okay, but before that, let me get back to my project. Now I'll push the changes. So just try to commit. To commit, just open up your git bash and try to write this command: git add space dot, then git commit -m, let's say CICD edit, then git push origin main. Now if I go back to my GitHub, now see, if I refresh here, so it will start running my action. Now just go to the action. Now see, my action is running. See, first of all, it is running the continuous integration. So inside continuous integration, first of all, it will authenticate with my AWS ECR, build the Docker image, push it to the ECR. Okay, everything will happen. See, automatically. It's just a one-time setup, guys. Next time, you don't need to set up it. You just need to write the code and push it to the GitHub. Automatically, it will push to the, let's say, AWS server. Okay, now see. So let's wait. Once this execution is completed, I will come back. So guys, as you can see, my continuous integration is completed. Now it is running the continuous deployment. Now what it will do, it will again authenticate with my AWS cloud, and it will pull that image from the ECR to EC2 machine. And if you go to the Elastic Container Registry right now, and if you refresh here, you will see the image. Okay, see, Docker image is been uploaded here. Now see, it is running the deployment. Now see, it is pulling the image. So once it is pulled, then we'll doing the port mapping. We'll create the endpoint, and we can access our application. Let me show you. So guys, as you can see, my execution is completed. That means both integration and deployment is executed. If you're not getting error, that means congratulations, it's done. Now I will go back to my EC2 machine. Okay. Now here in the EC2 machine, you will get one public IP address. Just let me show you. So this is the public IP address. Just try to copy and just try to open it. Okay. Now see, if I open it up, so it won't be opening because see, my application is running on port number 8080. I think you remember. Okay, so by default, port number 8080 is not set. So I have to do the port mapping. So what I have to do, I'll go back, go to the instance. This is my instance. Then I'll go to the security. Okay. Now here you will see one option called security group. Just click here. Now on top you will see edit inbound rules. Okay, just try to click here. Now I'll just add the rules. Custom TCP port number, just give 8080. Just select 000. Okay. And here you will see save rules. Okay, just click on the save rules. That's it. Okay, so rules has been added. Now I'll go to the instance again. I'll open it up. Now I'll copy the public IP address again, and here let me paste. Now you have to give clone port number 8080. Now see, if I hit enter, my application should be running. See guys, this is my chatbot is running. Now if I give any message, let's say what is acne. See guys, it is giving me the response. Now see, my application is live right now. So it is already deployed. Now user can use my applications. Now what you can do, you can buy a domain, okay, your custom domain, and you can publish this application to the audience. Okay. Now for the second time, let's say you changed anything in the code. Let's say you added some more function. What you have to do, only just need to commit the changes. It will automatically get updated here. Fine. So no need to set up anything from scratch. It's just a one-time setup. Once setup is completed, just try to commit the changes, it will automatically running. Okay, now you can ask me, if I close this terminal, will it work? Yes, definitely we can close it. Let's say I will close this terminal. Now if I again go to the chatbot, if I refresh, see, still my bot is running. Okay, so that's how guys we can do the CI/CD deployment. Now let me show you how we can terminate all the instance, like whatever instance we created. If you don't want to keep it running, otherwise it will charge you, right? So what I can do, first of all, I will stop the EC2 machine I've created. So select the machine, click on the instance state and terminate. So terminate will delete it. Okay, so it will terminate and delete the instance. Then after that, I also need to delete my ECR. So let's go to the ECR. So first of all, delete the image inside that. Just write the delete command. Now try to select and delete. Okay, then what I have to do, I have to delete the then I will also delete my I'm user. Okay, the I'm user I created. User, let's select and try to delete it. Medical chatbot I have to write here, so let me copy and let me delete it. See, everything is deleted. Now nothing will charge you. Okay. So guys, that's how we can perform the deployment. And this is the code. You can use this code as it is. Okay. The code actually have shared.
So guys, I think you have seen the entire deployment, and now you can use the same pipeline. You can use those same file, okay, for any kinds of projects you will be implementing. See, all these steps will be common. Only you just need to change your project there, and whatever .git folder, whatever Docker file I showed you, everything will remain as it is. Okay. Now you just try to implement any kinds of projects from your side and try to integrate the CI/CD pipeline with your projects. Okay, that means you can use those are the file as it is. Okay, only just try to change your project. So yes guys, this is all about. I hope you got it, how we can perform the CI/CD deployment. Thanks for watching.